Hello everyone, and welcome to first day of Qubes OS Mini Summit 2021. I'm Piotr Król, and I will moderate and co-host this event. With me, we have Marek Marczykowski, Diplo, and other Thierry from Insurgo and other speakers. So let's start with the introduction to the first day. So I will start with some history of the event. So event started in 2019 because Marek visited our Gdańsk office. He gave a training for our Linux kernel developers, and because we knew he's famous from the Qubes OS maintainership, we asked if he would be able to share with us some thoughts about Qubes OS and about the problems that we see. And we turned that into the Qubes OS mini summit event. And that was the first event that we did. And we agreed that this was a good thing, and maybe we should continue that in future. There was no recordings, but the presentations are online on our website, and you can go to this link that I'm showing right now to see what we showed back then. Second event was in 2020. It was held virtually because of the pandemic stuff, but videos and presentation are also online. You can watch everything on YouTube. There was the event was extended through Ask Me Anything session after the presentations. We will have similar concept today, but maybe let's say what's changed since last year. First of all, we were able to do some joint marketing with Qubes OS team, and thanks everyone who make it happen. And I believe thanks to that we have way more people watching this event. So thank you very much for joining. We get through a little bit more formal call for papers, and thanks to that we have talks from the community members and more Qubes OS team members. And thanks to that also we will not only talk about the security and about some high-end features of virtual machines, but also we will talk about Qubes OS future, about user experience, about backups, cryptocurrency, and many other things. So overall, I hope you will enjoy this event, and feel free to provide us feedback if you think we can improve anything with it. How we will operate today. So the event is divided in 2 days. August 3rd today, first session, and second session will be August 10th in a week. And every session will be in format that between 6 p.m. and 9:45 p.m. UTC, we will have lectures and discussion focused on the presentations. But of course, if someone wants to bring other topics, feel free to do that. And after that, we will have kind of vPub, informal after party without recording, without any registration, I would say. And feel free to join us, and we can drink beer or whatever you want and discuss future of Qubes OS, ideas around it, and maybe other topics related to the security of the operating systems. So how the schedule will look like today? So we will start with this introduction. I believe I'm moving way faster than expected. Then Marek will start with Qubes OS 4.1 highlights. So I believe we will get information about what's coming in 4.1. Then we will get first impressions count onboarding Qubes user through an integrated tutorial. So Diplo will provide more information about how to enter Qubes OS land and what kind of obstacles you may face and how cool Qubes OS is, I believe. Then we can take some break. I believe this break is quite long, and we can decide if we really have to take half an hour or it can be shorter. And then we will have Thierry Laurion from Insurgo talking about backups, especially Wing backups, and he will tell how to use that in Qubes OS and backup everything, including DOM0. Then there will be final my talk about SRTM and Secure Boot for VMs. Yeah, and that would be the end. And we can switch after that talk and after discussion, we can switch seamlessly to the vPub, and then everyone kind of would be invited to discuss everything open on the Jitsy session. And I believe that's it. I just started to write the future ideas. First thing, I believe it would be great to know the statistics, because the statistics this year seem to look differently, a little bit better than before. I already see that 71 people watching. That's great. So yeah, if you will have any feedback about how we can improve things, please let us know. So I don't know, like, do you feel, Marek, we should start with first presentation and just kind of break a little bit the rules about the precise schedule to the minutes?
Yeah, I think that's fine.
Yeah,
we'll
so
have more time for questions.
Sure. Okay, so let's start with the first presentation, where Marek will show Qubes OS 4.1 highlights.
Hello, my name is Marek and I will talk about what's new in Qubes OS 4.1. What exactly is Qubes 4.1? It's a result of over 4 years of work, and the main new experimental feature is GUI domain, GUI cube, but also we have several other changes, like new Qrexec policy formats, several UI improvements, better HVM integration, and also a lot of software version were updated. In this talk, I will include some some description or some details of selected the most important features, but a lot of them there are too many of them to fit in this talk, so you can take a look at draft release notes for more details. There are some comments, and there are also the actual content is also partially prepared there already. Okay, so first of all, what's about this GUI cube? In Qubes 4.0 or older, the desktop environment is running in DOM0. And also DOM0 is the place that is responsible for managing all the domains, or that is responsible for configuration, for storage, for all the system functions. In Qubes 4.1 we are introducing experimental feature support for GUI cube, which is for running separate VM for desktop environment. This means, first of all, you can finally meaningfully isolate and maybe even limit what the desktop environment can do. But also it allows in the future several new use cases. For example, multi-user support, maybe virtual desktop infrastructure based on cubes, but also having disposable GUI cube, it's possible to have kind of guest mode. Okay, so how does it work? We have 3 modes currently for GUI cube. First, the classic one, well, the primary one with GPU connected to the GUI cube directly as a PCI device. This way it looks and behaves more or less like it is in the DOM0 case, with of course with the limitation that it's, well, not really DOM0, so all the actions you execute in such GUI cube are using admin API to be executed in appropriate place, in most cases in DOM0. but with GUI Cube you can actually control what is executed where and what actions are allowed. Another possibility is using some networks protocol to access your desktop environment. As a proof of concept, we've prepared configuration with VNC server, but it's possible to use any network remote desktop protocol. And finally, there is a hybrid GUI cube for the case where GPU pass-through does not work reliably on a particular hardware. In this case, a GPU is connected to DOM0 and is using Qubes GUI protocol to display a desktop environment from a GUI cube. So let's take a look at the network case. This is a view you get after you log into the GUI cube using VNC. Looks pretty similar to normal cubes. So how does it work? You can interact with the menu, and as you can see, there are a few less VMs. Also, the VDAT is working. We can list VMs, more or less because like normal cubes, but some VMs are missing. Sysnet, sysfirewall is not here. This is because Qrexec policy for admin API is configured to hide them. But otherwise, you can start VMs, you can interact with them. You can, depending on the Qrexec policy, you can even create new VMs and have them accessible here. So we can go to Qubes website. In the personal cube, we can create and start new disposable VM, for example. So this more or less behaves like a normal cube system, but with the because it's running in a separate VM, it's possible to specify, to limit what this cube is allowed to do. Okay. So what next? There are several Qrexec improvements. Because GUI cube requires is using admin API to execute a lot of actions, and this puts a lot of more performance and configuration requirements on Qrexec. So first new feature of Qrexec is about socket services. In the past, Qrexec service is a separate application, a program script binary that needs to be started for every single call. This means, in case of, for example, Python scripts, the startup time is quite long. So in Qubes 4.1 we introduced another mode of starting and connecting to Qrexec services. It's using Unix sockets. So instead of script, you set up a symlink to a Unix socket or Unix socket directly in Qubes RPC directory. When Qrexec tries to connect to such service, it opens a connection to Unix socket, and then at the beginning send all the connection metadata that normally were sent to the service using program arguments. So now it's they are sent over this socket connection, and after that, there is normal data from the normal data channel to the service. This allows a much quicker startup, much quicker connection to a service, which is especially important for admin API, which is using a lot of short connections. But it also allows using a single process to handle multiple calls at the same time. And the other case, case is useful for window icons. This is a Python daemon that is importing a lot of graphics libraries for converting those icons and drawing them, etc. And it's using about 20 megabytes of memory. In Qubes 4.0, it was separate process for each VM, which was using quite a lot of memory in DOM0. In Qubes 4.1, we have one daemon that is handling all the icons for all the VMs, and it's using much less memory this way. There are also other the more details about this is in the dedicated article linked below. Okay, what next? There is new Qrexec policy format. The Qrexec policy now is combined from multiple files. So instead of separate policy for each service, we have a common policy for all the services, and this policy includes also information which services and which arguments it should be applied to. This allows easier auditing the policy and specifying global rules, like nothing can call into vault, some valuable cube of vault or something like that. But it also allows to better split the policy into logical files, like here default rules, here user rules, and here rules for some specific application that consists of for example 5 Qrexec services. So it simplifies the maintaining the rules maintenance. There are also some minor improvements to the rules, like ability to show notification when the call is allowed or denied. And there is also ability to allow a call, but only to a already running cube. So how the new format looks like? Very similar to the old one, but at the beginning we have two extra columns. First is for the service name, and the second one is for the call argument. And as you can see in the third column, both columns can have some wildcard value to apply them for to all the calls or multiple calls. And another improvement is policy daemon that is responsible for caching the policy, which also means a lot faster connection time. Yet another improvement for admin API. Okay, so what about UI improvements? First of all, Qubes Manager got a lot of new features, like selecting multiple cubes and applying an action for all of them, like changing a template or changing a NetVM, things like that. There also the internal structure of the code structure was also significantly improved, and also the cube setting dialog got some new features, like setting for GUI daemon. Currently there are just a few checkboxes, like allowing UTF-8 characters in the window titles, but we will add more in the future. And finally, there are also some improvements to create new cube dialog, for example, setting initial memory or better descriptions. As you could notice on the GUI cube demo, there are new beautiful icons, separate different icons for different cube types. There's also an icon for DOM0 with a crown. And related to that, we try to use term cube more consistently in the system. It's not fully transformed yet, but we are migrating to this terminology. Another feature that was frequently requested is a mouse cursor shape. Please take a look at the mouse cursor here, how it changes now when you move it around. Previously, VM had no control over the mouse cursor shape, and now it's possible to use this visual indicator too. And finally, we have better disk space monitoring when not only DOM0 is running out of space, but also a VM, individual VMs is running out of space. We get a notification, and it's also possible to see a list of VMs that are running out of space and either ignore it or open settings to make some increase the VM private volume size, so it's easier to spot when you are running out of disk space. Okay, next topic in 4.1 is better HVM integration, specifically for audio support for Linux cubes. We have just Pulse Audio plugin, Pulse Audio module that is connecting to DOM0, or in Qubes 4.1 it's possible also to have audio handled in dedicated Qubes audio. So it's a Pulse Audio module. This means it requires running Pulse Audio, which is a Linux daemon. So we didn't have audio on Windows, for example. In 4.1 there is support for emulated audio card for HVMs. So this is a kind of combined solution where Pulse Audio with appropriate module is running in a stub domain, and this stub domain is connecting to QEMU, which emulates audio cards to the HVM, and this HVM see the audio card as a normal device, so it's possible to use that from basically any operating system. There is similar thing for USB devices. So in 4.0 and generally for VMs with native Qubes support, we use USB IP driver and connect to it using Qrexec. This is again Linux only solution. Well, theoretically there is USB IP implementation for Windows, and we also have a Qrexec agent for Windows, but this is not easy to integrate, and also not the USB IP for Windows, it's not really maintained. So we are using a similar hybrid solution, combined solution, where USB IP is terminated in stub domain, and then connected to QEMU, which emulates USB controller to the HVM. This works for simple devices. It may not be performant enough for things like USB camera or other high throughput or low latency devices, but it is some initial version that could be optimized later. And finally, Qubes 4.1 brings a lot of updated software. Specifically, there is new Zen version, so instead of Zen 4.8 in Qubes 4.0, we have Zen 4.14 in Qubes 4.1. There are a lot of changes in Zen, too many to fit them in this presentation, but there are some highlights include a better UEFI support. Specifically, it's again possible to start to have a group bootloader in UEFI. This allows easy way to choose which kernel to boot, choose which Zen to boot. If something goes wrong, for example, it's much easier to recover. But also there is the opposite feature where all the boot files, including Zen, DOM0 kernel, kernel parameters, intramfs, etc., can be combined in a single unified Zen EFI file. And this file can be signed with user-configured secure boot keys. So this allows to use secure boot in a kind of meaningful way. It's still not a full UEFI secure boot support, but it's a step in that direction. And finally, this in this new Zen version brings core scheduling, so it's possible to use hyper-threading in kind of safe way where all the threads of a given core are always assigned to the same VM. So if someone finds yet another speculative execution bug that allows to leak information between threads on the same core, with core scheduling, that would only leak data from the same VM, so it won't allow leaking data from other VMs. In Qubes 4.0 we disable hyperthreading for this very reason. In Qubes 4.1 hyperthreading is still disabled by default, but then support core scheduling, so it's possible to enable core scheduling and enable hyperthreading again. So if someone need some more CPU power, it's also an option. Then we have newer DOM0. DOM0 is based on Fedora 32, but with introduction of GUI Cube, the desktop environment is no longer strictly bound to the DOM0 version. So it's possible to start to use GUI Cube based on other template like newer Fedora or Debian or something else, and then have that as the desktop environment. So in case of GUI Cube, the DOM0 interface, the DOM0 distribution is very much hidden from the user. In the future, we plan to use some stripped down minimal Linux in DOM0, but for that we need to stabilize the GUI cube to have it the default and the only option, which is not yet the case in Qubes 4.1. And finally, there are new templates. So there is Fedora 34 in testing already. There is the Debian 11 in testing. This is not strictly related to Qubes 4.1 because those templates are available for Qubes 4.0 too. But I included them here because this is also something done while working on Qubes 4.1. Okay, so this is a short introduction of what's new in Qubes 4.1. Thank you. Qubes 4.1.
Okay, I was with that. That's great, like Marek. That's wonderful presentation. I see really a lot coming to 4.1, and I already have my top choices. I already asked our live stream listeners and watchers what are their best features for 4.1. We already have one question, so let's maybe start with that. So the question is from DPC Prince. Will Qubes 4.1 use audio VM for better Bluetooth support?
So by default, the basic default configuration remains pretty much the same as Qubes 4.0, like the GUI and sound is handled by DOM0. But it's possible to choose any VM for handling audio. So if you have USB Bluetooth controller plugged into sysUSB, you can choose to use sysUSB to handle audio too. And in theory, this should work seamlessly with Bluetooth headset or something like that. To be honest, I have not tested this specific configuration, but yes, in theory, it should be much easier to use Bluetooth audio in 4.1.
But if we have laptop, let's say, and we have like Bluetooth controller somewhere on the board, I don't know how those typically are connected. Maybe those are still connected through USB
Yes.
Controller, so this still applies.
Yes, exactly. I think in most cases, or maybe even all the cases, the Bluetooth controller is a USB device, even if it's internal. But even if it's not, like even if it's a separate PCI device, it's still possible to attach this PCI device anywhere you like.
Mm-hmm. So we already have some first answers. So people like HVM stuff. So Mike saying about hardening. So never too much security. And more improved GPU support is also a great thing. I believe I also very like that. But FX Screencaster asking for is it too much of an open question? But what are the security implications of GUI cube?
Yeah, so it very much depends on the configuration, especially for the policy. In the case of simple single user configuration, when the user is also the system admin, their GUI cube is can do almost anything, pretty much the same as in previous releases. The major difference here is all the actions are coming through Qrexec policy. So first of all, you get you get them logged whenever GUI cube does anything.
Wow.
But also it's possible to limit those actions and, for example, have separate GUI cube for normal operations and separate some admin interface for administrative actions. This is more useful in some managed configuration like corporate environment in practice, this limited configuration, but there are many options like the guest mode or kiosk mode or something like that. And finally, in some future version, some real multi-user support.
Yeah, I love that. I love the thing that you can limit what's going on in GUI domain. I'm just wondering a little bit about the performance, but I assume that the Qrexec performance improvements are related to that.
Yes, exactly. So the performance impact is noticeable. It is slower to, for example, QVM LS is executing slower in GUI cube, but it's not that bad. It's quite useful. And for the graphics performance, if GPU pass-through works on the particular hardware, there should be no impact on the graphics performance. It should work as good as with graphics in DOM0.
But we have quite good discussion here. I even see some guests joined, like I see Trammel also joined discussion. That's great. We have so notable watchers here. But let's try with the next questions. What will be the default file system in the 4.1? Are you switching to Btrfs, or you will keep provisioning LVM for DOM0 storage?
No, the default stays the same. The default is still LVM thing provisioning and ext4 file system for DOM0. There is one significant improvement for the default configuration. DOM0 gets separate volume thin pool, so it's no longer possible for VMs to fill up the space for DOM0. So this space is separated, but otherwise the default still is LVM.
Okay, so the next comment is so this is another comment about GUI domain, but that it looks interesting. I believe this is like the biggest and the greatest improvements here. What's the next? So if the Qubes 4.1 going to keep the whole Unix template as default?
Yes, they are still available in the installation media. One change to the templates we've made, the installer allows you to choose not only whether to install a given template or not, but also allows you to choose what is the default template you want to use for all the VMs, like the default VMs, the system VMs, etc. So it's possible at the installation time to choose either Fedora or Debian. Whatever you prefer.
So Trammel saying that it's great to have unified Zen and preliminary secure boot. I believe like we are on the same page and like it very much. So any thoughts about how to improve the PK DOM0 inter the Zen signing process? Yeah, so I believe this is a little bit related to my talk, which will be way later. But still, I'm not answering this question. So, Marek, if you have some ideas about that, then
currently this is quite manual process. We don't even provide the script to build this unified binary yet. This actually may change in the final release, but still, this is a manual process. As for YubiKey, it is an USB device, so we could allow connecting USB device through QVM USB to DOM0. It is not the best possible idea because USB devices are way too complex, but it is some option. We don't have really any convenient solution yet. So yeah.
So I just wondered like how this can be solved. I believe USB devices are problematic, but what's not, like any smart card stuff will be problematic. TPM may be some solution, of course, if we will have open source TPM and open source hardware TPM. But that's something that LPM Plant, my other company, working on, and we already have grant for that. So maybe that will improve things. But I wonder about the signing process, because I'm also kind of confused how this can be handled. Because one path is for the secure boot, devices with Microsoft CA stuff. We have the situation where we have to use shim. Otherwise, there is not much what we can do. Or we can sign something of our own, but who will go to Microsoft and get through process, because it have to be some entity that does it. And if not, then we have every update, we have to kind of resign everything, with our own keys, which are provisioned on the platform.
Yes, exactly. So the unified Zen binary is mostly targeting the second case, where you provision your own key into the platform, and definitely there need to be some tooling to automate the constructing this unified binary and resigning it on every update. So this is something that definitely needs some tooling. Which is currently missing. As for the Microsoft signed boot files or shim in practice, we don't have this established yet, and maybe one day we will have, but we need to solve some cases how to do that meaningfully, because obviously in that case we need to provide the pre-built binary and pre-built signed binary, and not something for the user to build and sign, because the signing keys. But then we need we give a lot less flexibility to the user what should be started. This combines Zen kernel, Zen version, kernel version, and possibly other boot files like intram.fs, or maybe even boot options into one single signed blob. So it's we still need to provide, for example, some method to troubleshoot if your hardware needs some extra kernel options to boot or something like that. We need some more design. We need to think about such details more.
Yeah, so I would say, of course, the first case is more interesting for me, like taking ownership of the hardware. I believe many others, like I believe Thierry is also with us, and he's also on taking ownership of the whole platform and software stack by the user. So I believe this is way more interesting. But on the other side, I have candidate for the project who may integrate that, because I believe SafeBoot is partially about that, and having SafeBoot in a place where it can provision hold the system, and sign everything, and help drive the process. I believe Trammell already started that, so it would be way easier to integrate SafeBoot than trying to invent something completely new. But it's up to Marek, your choice, and Qubes OS team choice how to use that, and if this even makes sense in light of SafeBoot future evolution. But I believe this may be good synergy here. Okay, so let me move on with the comments. There are some comments that streaming SteamOS or PS5. To be honest, I'm not sure like what's the use case for that and how this help, but MIG saying that this GUI cube could help with that. A remote GUI cube is the future, he's saying, or she's saying. Interesting So where does the Qubes OS team stand in terms of security when it comes to the new Copilot AI accessing the open source code of the Qubes OS team in the GitHub platform? Oh, okay. So this is like this GitHub Copilot AI learning from Qubes OS code base. What's going on? I believe this is like interesting question.
Yeah, so well, our code is most all Qubes code base is open source. In most is GPL2 license, so you are free to use. And if some AI can learn how to write secure software, that's I think that's a good for overall software, right?
Yeah, we will see how this will end up. Like if we will not have like something like Ghost in the Shell world or something like that, but
Yeah.
but definitely this is interesting question, and I believe this is great question for vPub, because I would be definitely in mood of discussing that deeper. Okay, I see. Probably Thierry asked this. Sys GUI with GPU pass-through, salt receipts, card coding, Intel PCI ID. When enabled, will laptops get PCI pass-through for single Intel GPU on boot? Wow, that's kind of complicated. I have to think about that.
Yes, so this is exactly the case for the salt recipe we provide by default. We have some patches to make it work specifically for Intel graphics, and with some tests, it looks to work more or less reliable. It may work with other graphics too. We haven't done any extensive tests. I have one machine with NVIDIA card that does not work this way, but otherwise it's just some default we needed to fill there to make it as easy as possible to set up, to try it out. But also this is remember that this GUI cube is still very much experimental feature, and this is something that the final stable version of GUI cube will definitely have some smarter configuration.
Yeah. That's great improvement. I believe this is like major milestone in. I wonder also like how this because we discussed that this switching of the hypervisor, and like isn't this that it's very tied to the kind of Zen environment, or this is portable to the KVM?
This is actually an interesting question, because from what I know, the GPU pass-through works much better on KVM than on Zen. So there is some work on getting KVM support in Qubes. It's not really complete, but there is some progress. It's mostly in terms of in context of power platform, but most of the work is generic now, if applicable to other platforms too. And also nothing specifically for GUI cube is tied to x86 platform or Zen. So this all is using the common interfaces we have defined in Qubes. So if those interfaces get ported to KVM, GUI cube will work too.
Okay, that's great. And even it may benefit from KVM GPU pass-through, but better support there.
Yes, exactly.
But we will see how this will go. I still believe there is a lot of value in Zen as a hypervisor for Qubes OS. But anyway, let's move on. Next question was about where will be presentation. Of course, presentation will be on 3mdeb website as all the years before. And I already posted the link. So we can go to the 3mdeb events website, and there will be presentation there. I believe this week we'll publish that. But please give us a little bit of time. Any hints about the release date for 4.1?
Oh, I was sure this question will show up.
How we can avoid it?
Yeah, so my plan is to have a release candidate this month. I think with the beta 1 working quite well, this is the realistic plan, and then we have a schedule which says basically every month a new every 5 weeks, I think, a new release candidate, and with the amount of changes is 4.1, there will be probably 4 or 5 release candidates. So it's early next year, the stable 4.1.
Mm-hmm. I thought that the answer will be contribution is welcome.
Well, okay, always.
But I believe always, yeah, that I believe that this also applies. Are there any changes in the management stack, salt stacks for 1? Any changes? Do you see any changes there?
Not really. So this part remains mostly unchanged since compared to 4.0, and well, there is as usual with updated DOM0 and updated templates, there's newer salt version, but otherwise this is pretty much the same.
Mm-hmm. So with salt stack, like salt was applied by, I don't know who, VMware or someone acquired.
Yes, I think VMware.
Yeah. So does it affect things by any way? Like, I know you like salt. Like, to be honest, I always have hard time to get into that because I always have like 2-3 hours to learn it, and I always struggle to get through, like, to get something very meaningful. I have terrible salt scripts, and yeah, I would be glad to have maybe better documentation or understand it better to improve my Qubes OS setup, and just wonder if this still makes sense to invest in salt.
Yeah, so this is something that mostly works for us, and yes, the issue with salt is the learning curve. Like this is salt introduced a lot of terminology that is not very obvious, but the actual concepts are pretty much the same as in Ansible, but just the terminology is much more confusing. So there is some community contribution for integrating also Ansible, if someone likes Ansible more. I have not looked into that too much, but it exists. But otherwise, I think as long as salt works for us, it's something that will remain present. Maybe in the future, as there will be more options integrated by default, but that's the future.
Yeah, so I just wondered about salt stack, and it looks like still makes sense. And I saw Ansible stuff, but it's kind of like, for me, Ansible is easier, definitely, but still, it's not native integration with Qubes. Yeah, it's like it's better to use salt, which is kind of more native for Qubes. Thierry, get back to the topic of to be honest, we kind of lost the thread. We got the last 5 minutes of discussion. This discussion is like, it's great. Like, we have not despite we started early, we don't have enough time for discussing all these comments. And I have like a bunch of notes here that I even didn't start it. So I didn't started my trolling yet. But what about this? Do we have acceleration? But I don't know what's the context of this question, Thierry. If you can or maybe Marek, you catching what he's...
Yeah. My question was about like the GPU pass-through with the Intel SRTM, the default one that is pushed. The question was, do we get acceleration? Which is a question that is coming from all the gamers all the time.
So the default in the Qubes 4.1, no. So the GPU is accessible only to GUI Cube. You can use its full power in GUI Cube, but it is not where you are running your applications. Or at least should not be the place. But this is something we consider a prerequisite to work on some GPU pass-through to actual app VMs. And this is very complex topic, and this is definitely not coming in 4.1.
Mm-hmm. Okay, what else we have here?
I see a question about is it from a question from Demi? Is it limited to NVIDIA, or does KVM also have better support for Intel and AMD pass-through? I think it's not really limited to NVIDIA, and it's generally better, more robust PCI pass-through in general in KVM. So it works better with GPU too. And then there is a question for Alimir Jamali about any ideas on hardware requirements changes compared to 4.0. Not really. All the hardware that was fully compatible with 4.0 should also work with 4.1. The opposite is true. With the updated software, some newer platform that were not compatible with 4.0 should start working with 4.1. Okay. Do we have any more questions here?
Yeah, I believe we have 3 minutes to the next presentation, so we can take some last stuff. Once there was a talk going around interesting subgraph OS with Qubes OS. I don't know what subgraph OS is. Any progress on that?
No, I think this topic have died, and in fact, I am not sure if subgraph OS is around anymore.
So what was subgraph OS, if you can tell our audience?
Subgraph OS was an attempt to do something similar to Qubes, but using containers as a base technology. And containers and I think Selenium.
There was Rancher OS, which did quite well, this thing. It was killed, I believe, by some bigger players. I don't know if Docker just not. I don't know. Something bad happened with Rancher OS. I relied on that heavily. It had all the services containerized, and I liked it for provisioning kind of thin VM in Proxmox on the server when I wanted to, do some quick service setup. But yeah, so it looks like subgraph OS got similar, but this was more for desktops, yeah.
So for subgraph, it was mostly tightly integrated with GNOME, so you could have nice widgets for the state of individual containers and stuff like that.
Yeah, so a lot of questions. I believe some of that we will move because we have last 2 minutes. Like Marek, you can pick something like 1 minute left. So let's pick one and then let's.
Yeah, so I think I see simple questions here. WireGuard VPN support. We do have that in kernel, and if you can use it in your VM, there is not really any integrated support like scripting or something like that, but it should work like on any other Linux. And then any ideas on AMD Ceph for securing VMs? Not yet. This is something we may look in the near future, but it's out of scope for 4.1.
Trammell, if you want to join, you want to join Jitsy and talk about security features for VMs, it would be great, and probably the best time would be around SRTM and Secure Boot talk. That would be like, I don't know, in 2 hours. Yeah, I would say, if you have time, of course. Okay, so Norbert, I believe you can schedule next talk.
Hey all, Diplo here. So first impressions do count, and for all of the power that Qubes puts in our hands, it also comes at the cost of training, learning, and for many of us also frustrations and a sense of powerlessness while we're still adapting into the Qubes way of thinking and its specific particularities. And this is what I've learned by talking to some users and also experienced myself, even though I had come from Linux before going into Qubes. So in this talk, I'll present to you some of the challenges in learning Qubes that I've identified in the context of my master's dissertation, and the solution that I'm proposing and is still in development, which is an integrated onboarding tutorial. So I'd like to start off with a bit of an exaggerated experience of someone learning Qubes. And so at this point, they have Qubes installed and they've gone already through the whole process of installing or for example finding hardware, which may already have decreased a bit of their confidence. So here we see the evolution of confidence over time, and the user boots the operating system for the first time, and they open certain Qubes and certain applications. They play around with it with the menu, which is the most visible part, I would say, and they keep doing it. They open some other Qubes and they explore what they have there, the applications that they have, and they feel powerful because Qubes does give that sense. But quickly they get a warning message saying not enough RAM, and this may come as a surprise for some, maybe not for others, but it may take the user a bit of time until they can find the Qubes widget or the domains widget, or for example the Qube manager, in order to shut down the currently running Qubes. And then their confidence goes a bit down as they're trying to install the software, because it may not be immediately obvious how to do that. So maybe they go to documentation, or maybe they are a bit frustrated and try to install it like a regular Linux system, which apparently works. They use the terminal to install it and they feel confident, and only for that confidence to go downhill, because once they restart the system, it disappears. And at this point, many users may be like this. So currently, only with much perseverance and lots of documentation reading, and even some scary looking terminal actions, can one go over the initial bump that allows us to access all of the Qubes features. But Qubes is extremely powerful and extremely necessary, and there are non-technical users who happen to also be vulnerable users that really need the security of Qubes, and so they need Qubes to be a tool of empowerment for them. And these are people who need a system that is secure, that they can use to carry out the work that they do without too much frustration, and ideally without having to go through extensive training courses. And this is currently being tackled from multiple fronts. For example, on the usability side, Nina and Marta are currently working on redoing the Qubes menu into something that is much more usable and that kind of introduces the user onto thinking about how Qubes works internally. And that's an excellent effort, and I think it will pay off. Also on the documentation side, documentation has been very welcomed by a lot of people, and compared to other projects, it's incredible, but it still needs some changes, and I'll talk about them later. And also on the training side, for example, on YouTube or on video platforms, there aren't a lot of Qube-specific videos that are built by community members, so generally only from reviewers. And this is something that really needs to happen, especially on the latest version of Qubes. And also on the training side, the Freedom of the Press Foundation has been doing some incredible work in onboarding users. And so before I started working on the particular solution of an onboarding tutorial, before I even knew I wanted to work on that, I did some research. I interviewed 6 community members who were already using Qubes to understand the basic learnability challenges they had when they were getting into Qubes. Specifically, the challenges and the solutions, like for example, where they found the solution. So on the first days, or I mean the first time that people were using Qubes, 3 out of the 6 participants described being confused. And this can be explained, or there was a quote from one of the participants that said that the first time they were in the system and they could see that there were the default app VMs, but they didn't have a clue of what to do. And this is exactly the kind of frustration that I'm trying to ease with the onboarding tutorial. There were other 3 classes of issues that users experienced and that I've coded into the interview. Namely, learning the mechanics, installing software or installing Windows even, or copying files and copying the clipboard across VMs was not immediately obvious, and they had to refer to external resources to find how to do that. Also, changing workflows was the challenge. For example, defining their compartmentalization strategy and like which Qubes to create, which ones to change, and also how to stick to that compartmentalization, because one thing is to set the list of compartments, another one is to actually using it every day. And lastly, there were also challenges regarding to the mental model formation. So for example, one user described that advice for a future user of Qubes would be not to have a mental model of a traditional desktop, like erasing what you know and starting from scratch. And this mental model issue has to do with the fact that Qubes requires a mental model of a hypervisor. So in a typical system, there on the left, that's the menu, and you have applications that you open directly. Whereas in Qubes, on the right, you open applications within a specific Qube or within a specific compartment. And this is a different way of thinking. And it also translates into the closing of applications. In a regular system, closing the application is just closing the window that it's in. Whereas in Qubes, in most situations, you need to close the window and also shut down the Qube when you no longer need any of the applications that it's running. So a very different way of thinking about it. Regarding where people solved or found the solutions for the issues, the documentation was referenced by all of them. And here we can see a word cloud of how many participants referred each terms. So there were also videos and some online forums. And regarding the documentation, I wanted to mention that the current version of documentation is written as a reference material, and it's highly regarded as a good reference material by a lot of people. But as you can see there on the right, since it's reference material, there are a lot of links. So each node is a page, and each edge is a link from one page onto the other. And navigating the current documentation, I think there is a great quote from a participant of the study which said, it's written from the perspective of you know what you're doing, and usually the time that you're looking for documentation is when you don't. So when people are already experienced with Qubes, it's an excellent resource. And so there needs to be some sort of other documentation that is more progressive and takes the user from knowing nothing into knowing how to do basic things. And there is a link there for a discussion on the forum into creating exactly this kind of resource. And also regarding the documentation, we know from research that users prefer to learn by doing, and that trial and error is much more frequent than going into a manual. And this leads us to the idea of making an integrated onboarding tutorial. For example, this is one of the earlier approaches to doing this that is documented in academia, and this is called the contextual procedural tutorial, and it's a series of overlaid sticky notes that point exactly to where the user is supposed to click. And this is also shown throughout the web in many websites that require a bit more complex interaction, and even on the Qubes forum. And compared to paper tutorials, at least in this paper, they found out that users made fewer errors and spent on average 26% less time learning, which is quite significant. And onboarding interactive tutorial is exactly what I propose as the solution, or one of the solutions for improving the learnability of Qubes. So I had 3 goals in mind. Firstly, to introduce the user to basic actions on Qubes. Secondly, build the mental model for the user to kind of break that expectation that you just open applications, and instead you open applications within Qubes and you need to shut down those Qubes. That was my goal. And also make it something short, because once the user is getting started on the system, they probably don't want to go through an extensive tutorial. So keeping it as short as possible will probably make it more effective. And this means that we can't include everything in there, like installing software, but that will be added as an extra tutorial, possibly in the future, but it's still outside of the scope of this. So now I'm going to show you what the prototype looks like. And keep in mind that this is just a prototype, so there is no code behind this, it's just a series of images. So when the user first boots into Qubes, they are presented with this welcome screen that explains a bit about Qubes, and it stresses the fact that Qubes is quite different from other systems, and they highly nudge the user into doing the tutorial, but the user always has the choice of skipping it. So learning the basics, the user clicks here, and firstly they're introduced to the idea of the compartments. So they have the personal compartment, the work, the vault, and the entrusted. These are the default ones. And then we also mention what a cube is, that the cube is actually just a compartment. And we don't mention anything about the virtual machine, because this way we keep it abstract for the user, which is the way Qubes is going. So then the user clicks, I get it. And we introduce the user to the mission, which is to copy a file from the work cube onto the personal cube. Here we use the colors to relate to the previous one, but users can always click there to see the previous one if they want to remind themselves what these cubes are. And we assure the user that we'll guide them through the whole process. So then the user is ready, and they get to the task 1, which is to open the file explorer on the work cube. And so here they, like you see here on the bottom right, something for them to always exit the tutorial if needed. But the user is supposed to click here on the cube menu, and then on work, and within work they select files. This takes a bit of time to load because it's loading a bit heavy images, but then the user clicks here. As you can see, there is a hotspot, a pinging thing, which shows you where you're supposed to click. And now it tells you that we have to wait for the cube to start. And this is introducing the idea that a cube is somehow related to a computer, so it takes more time just opening application. Then we go on to the second task, which is to do the same thing for the personal cube. So again, we open the Qubes menu, select personal, and then within personal we select files once it loads. There you go. And again, it's taking some time to start. And we're doing this in order for the user to see clearly 2 different file systems, or at least give the user the chance to notice that they are slightly different and that there are some colored borders. They probably mean something. So let's just wait for the cube to start. And then we tell the user that each cube is isolated. And we point to the fact that they have different files. So then we click OK. The tutorial is a little bit slow on this part because it's loading a lot of assets. So, but that's just a prototype. Then we talk about the importance of the color borders. We say that it has security implications and that the cube's name is always there within brackets. Then the user clicks I understand, and they get the third task, which is to copy the picture onto the personal cube. And this is the part where most participants found it odd because they expected just to drag and drop like a regular system, but that's not currently implemented. So they just follow what the tutorial tells them. Right click on the picture and copy onto another app VM. And now the prototype is a little bit slow again. But this is where we introduce the user to what a DOM0 prompt for permissions is. So for example, we call it here the administrator prompt, and we say that when a cube wants to do something onto another cube, this shows up, and the administrator cube has the gray color, and they have DOM0 there. And we also call out to the fact that this thing is important, the color is important. No other cube would be able, for example, to spoof this. And then the user gets taken to the real screen where they select personal as a target. Of course, in a real system, they would be able to type as well. And then, okay. Then they see it copying, and it lands on the Qubes incoming folder shortly. Okay, as you can see here, we say that it lands on the Qubes incoming. In a previous iteration, we had the user go in there and see that the file is actually there, but we'll leave that up to the user. If they want to explore it in the tutorial, they're free to do so. They only go on to the next step when they do the correct action. So last task is to shut down the Qubes. And here we do a little trick. We kind of trick the user into closing the windows in the expectation that that's all they need to do. And this thing should have popped up earlier. So close the windows, let's close it all, so we don't need that anymore. The user goes here, is expecting this to be what they need to do, and apparently it's not enough. They have to manually shut down each cube when it's not needed. And there is always the risk that the user thinks that in order to copy a file, they need to open the cube, copy a file and shut it down. But my hope is that they don't make that association. It's just that when they no longer need it, they shut it down. So they go here, select the personal cube and shut it down. And then they do the same for work. And this is again to stress the idea that a cube is something that you start and something that you shut down, instead of just being applications that you open. Because the user needs to manage these things when using Qubes, at least currently. And then the mission is done. The user knows a bit about how to get around Qubes, and then they can explore more tutorials. And this is the part where it has kind of like expansion packs. Just as you will see, each tutorial is just a tutorial definition file, so other people can expand upon this and make their own ones. And for example, organizations can create their own sets of tutorials for the employees or the beneficiaries. So here it just shows that this is the next tutorial, and they can either choose to play or skip, or for example see more tutorials, and if there is any one tutorial that they want to do, they just click on it. And that's about it, at least from the prototype part. The current progress is I started off by brainstorming about the contents of the tutorial. I designed a curriculum and I extracted what was the most basic things that I thought people should know about. And as you saw there in the tutorial, it was the opening of applications. It was the introduction to the meaning of what the colored borders meant. I also used the opportunity to show that file systems are different. And then I talked about what DOM0 prompts are. And then I also taught the users how to shut down each cube. And that was it. That was the basic tutorial. Then I implemented that into the platform that you just saw, which is called Figma. And I did 2 rounds of feedback with 4 to 6 users in each. So they tested the prototype and they were all able to conclude the tutorial without any help. But there was still some things to polish, and I implemented the feedback on the next version. And what you saw was the last version of it after these 2 rounds. And I'm halfway into the code's implementation of this. So regarding the architecture, most of it will be implemented in DOM0, which is the privileged virtual machine. And a tutorial is basically a series of steps with conditions. For example, if you do this, you go on to the next one. So it would make sense to have a file, a tutorial definition file there on the left, where all of the steps and all of the correct actions are loaded. And then the tutorial knows that the user did the correct action by looking at that. And it's constantly getting information from Qubes components and also some log files to see when the user did that action. And when the user goes into a new step, some information, some overlay is shown onto the user. So for example, it can be a modal screen there on the top left, or for example, a hotspot, which shows the user where they should click, or some information about the present task. Some challenges on implementing this. The first one is the hotspot, which is where people are supposed to click. This is non-trivial to implement, or at least from what I've experienced, because it is an element, it is a window that is supposed to be clicked through and also be attached to other components. So when the components change, these needs to reflect that. And so what I ended up doing is doing something like this, where I've changed the Qubes domains widget, for example, here, and added something there that just highlights. And this seems to be working best, at least implementation wise. I still haven't tested if this is good for users. Then the communication with other components is kind of necessary. So for example, there you saw the Qubes domains. It needs to have some sort of information from the tutorial on when certain parts should be highlighted. And I don't think there is a lot of leeway into this. So this leads necessarily to some high coupling between the components. So the tutorial depending on other components and other components depending on the tutorial. And I've tried to minimize this for non-GUI components. So for example, I'm reading information about changes in the system from log files instead of highly integrating it with, for example, with Qubes daemon. Not sure if this is the best approach, but I try to reduce the coupling where possible. And lastly, there is also the sys GUI, which will be a whole nother set of problems, because in a future version of Qubes, DOM0, the privileged VM which manages all others, will be isolated from the GUI rendering. And so that will be done on its own cube, which will be sys GUI. And probably the tutorial would run there, and that would mean that it would have access to much less information. For example, those log files would probably not be available, and that will have implications on the development of the tutorial. Probably will have to use some Qrexec policies to inform when something is happening, but this will have to be future work. So the next steps will be finishing the implementation and finally doing a final evaluation, some user testing, possibly remote, where we decide on what's the metric for determining if the tutorial was successful or not, if it increased, for example, the user's ability to learn to use Qubes, or if it didn't and it shouldn't be implemented, or it shouldn't be integrated into the Qubes, into Qubes itself. And I should also add the disclaimer that I'm doing this as part of my dissertation work, and it won't necessarily get included into Qubes. That will be, of course, up to the Qubes team and up to the standards of whatever I develop here. So I lastly would like to thank all of the participants who participated in the study and all of the people that gave feedback, especially on the issue, on the GitHub issue for this. And this is where you can find me. And you can also follow the progress of the implementation here on the issue below. And that's it. Mm-hmm.
Okay, sorry. I still saw that the stream is played on YouTube, but anyway. So Diplo, that's great presentation. I really love it and love the approach of the tutorials. We need that. We need more of that. And maybe this is good point to say that if anyone watching or anyone involved in Qubes OS see that sometimes we're going too deep and we are too everyone saying something too complex, which significantly raise the barrier to enter for new users. You should speak up and just say, like, if you can explain this or explain that. I believe this is very important because definitely Qubes OS has kind of complex architecture. Maybe at the beginning was not the easiest operating system, but got other properties which kind of beats everything else. But of course, I believe that the tutorials are needed and simplification of everything is needed. And I believe I have still issues with audio.
I can hear you fine.
Yeah, sorry, I just get message from other messenger that there is problem. So what I want to say is just definitely we need these tutorials to enable new users. That's one thing, and this is a great approach to that, and hopefully we can grow that. And I believe Marek research showing and probably survey stuff said that UX improvements would be great for Qubes, and it's needed for maybe less technical users.
Mm-hmm.
Yes, definitely. This is very, very useful and great work. And the tutorial looks really nice. This is fantastic work. I have one question about the shutting down the cube. Because we do have a feature to automatically shut down the cube that is not used for some timeout. I think by default 15 minutes. This is not easy to find or Qubes 4.0, but in 4.1 it is just a checkbox in Qube settings. What do you think about this? Is it should it be based on your research or something, should it be the default or should it still be some optional if you are comfortable with something like this?
Yeah, so in my research, I didn't specifically investigate this. I think it could be a good idea, especially like if users don't have to macro manage all of the cubes that they're running, that would be just ideal. It would be something that I remove from the tutorial. The more stuff that I remove, the better. So I think it would be very welcome as long as it doesn't create confusion on the users.
Yeah, I believed if we going to extreme with all this, because I see Diplo, your presentation and your research showing precisely where are the some problems, because you watched people using Qubes or at least surveyed people using Qubes for first time. New beginners, maybe not very familiar with this kind of technology, but I believe then when we're going this to the extreme, so we completely remove knowledge about multiple domains. Yeah, so because we can just we can just pre-configure everything that emails have to be separate from, I don't know, this is your place where you're doing banking stuff, and this is your place where you're keeping secrets, and so on and so on. So you can, to some extent, create a kind of template set of VMs that fits some special use case, and then of course you avoid the situation of teaching about every, how to create new cube, like what kind of parameters you can choose, and does it provide networking or it doesn't provide, or what memory have to be assigned, what template you have to use, and so on, so on. And to finalize this comment, it kind of sounds like it may go in the direction of Bromium. And Diplo, I don't know if you know Bromium, but Marek definitely know Bromium. So this is like a VM for every tab in the browser. But this is very extreme side. So that means like everything is hidden. Like user even don't know that this is really VM. I don't know how far we should move with this simplification, and what do you think? Like, is there any end on simplification and improvements from that side, or maybe this can be fixed in other way?
Yes. So I'd like to start just by making a comment about the research that I did. So it was with only 6 users, and so it wasn't very extensive. It was more to identify what were the classes of problems that people were having, and some users were new to Qubes recently, relatively speaking, and others were using Qubes for many years. So that's the kind of feedback that I got. Then you were speaking about the simplification of Qubes, and I think there is a certain barrier that you can't go below. For example, Qubes is kind of on the model that people have to more or less understand the compartments that they have, or at least the ones that they usually interact with. And from my interviews, I realized that some people were very, very thankful for the default templates because it allowed them to build their own compartmentalization strategy on top of it. So it provided a good basis. And I think that should always be kept. And like, I don't want the complexity of Qubes to be removed or put completely under the hood. I just want Qubes to be more learnable. So you start using Qubes and you can use it just fine. But if you want to dig deeper and do more interesting things, you will have to go a bit under the hood and understand, for example, how templates work. But I think in an ideal world, a user, in order to install software, they wouldn't have to understand that there is a thing called a template and there is a cube based on it. So making these kinds of simplifications that allow one to get started from day one.
Maybe, I don't know, Marek, do you have any comments about that?
Yeah, so I think that regarding software installation, one thing that is currently stupid that it doesn't work is the graphical packet manager.
Exactly.
This is something that is broken for a long time, and yeah, there is some stupid interaction with the updates proxy and GNOME software that we used to have there. Yeah, but this is something that sounds simple, but if we want to preserve the template isolation from the network, so that really only package manager can access the network, this is actually something that is quite tricky to solve properly.
Yeah. What about like to what extreme we should go with the simplification? Because I believe, like, you know the Bromium case. Like, do you think we should, like, Qubes OS should go in the direction of extreme simplicity, or there is you agree with Diplo with the approach, like there is people have to understand certain basic thing, and this is the barrier that we have to enforce?
Yeah, I think that too much simplicity here is a wrong approach, because Qubes has as a value in very explicit partitioning your data and your actions. Take a look, for example, at all the mobile operating systems, where you have isolation between applications, but it's implicit. Like if you start an application, it is isolated, but you don't have really control what application is running in what compartment. You have just one compartment per application. And this means, for example, that you you have no easy way to separate your work data from personal data if you use the same application for them. Well, there are some profiles, but it's quite hard to use in practice. So this is something Qubes is good about, that you can quite easily have the use different compartment for different data sets, even if you use the same application for both of them. And something this is also important for data flows, like you want to prevent some your work data leaking into your personal data space and the other way around. And this is with explicit partitioning, we can actually try to enforce that.
Okay, yeah. So I always like the popping up information that, you just, right now doing some operation like using keys from Vault, or you using some policy and you have to explicitly approve that. I always like this part. I believe I use it a lot. Like even I sometimes going to remote machine when I want to do Git commit. I know that this machine is secure. This is machine from my home lab. But thanks to all this GPG2 and SSH agent and GPG agent, I can use my keys, which are like securely living in Vault. And of course, if someone will try to do that, I will see the pop-up, and of course, I have to approve the pop-up on the screen. And the screen is only in my office, in my home office. So I always like this feature, and kind of this gives me kind of like feeling of additional control and additional security. So I believe this is valuable, at least from my perspective. Okay.
I totally second that opinion as well.
Yeah. So that's great. So let's look at the questions that we have from the audience. Is source code already available for this Qubes tutorial?
Yeah, I haven't released it yet because it's across various tutorials. I started doing proofs of concept for the little components, but once it's available, I'm going to share it as well as under the license that Qubes is released. But before that, I would like to make a decent initial commit where everything is organized and documented. But if someone is extremely curious about looking at the code, I mean, I have no worries in sharing.
So did you mention any points of contact in the presentation? Because
oh yes, in the last they have my email, and I'm also on the forum. I'm always there.
Okay. So if you would like to look into that, then yeah. FX Screencaster saying, I actually think there should be an option to shut down Qube if there are no more windows of that Qube open. I believe, Marek, you said that there is something like that. 15
yes,
minutes.
Exactly. Exactly. This is something it's already implemented exactly like this. It monitors for open windows in that particular Qube.
Is that, we have to. Is that the same as the shutdown idle program?
Yes. This is the one.
I believe we have to explain that better because even fans of Qubes OS which coming to Qubes OS Mini Summit do not know this function, and I believe Diplo also didn't know or thought about that function.
I knew about it. I just didn't know there was a GUI component, and that's cool.
Okay. So I believe this feature needs probably more marketing. There are some
yes, and in fact, I just find out that there is some typo and the checkbox is inactive.
So you'll see that it will Qubes OS Mini Summit will move Qubes a little bit forward. Okay, so Alex Smirnov mentioned that we should disable package kit for template-based VMs. It is misleading to say the least. I don't know what's exactly he's referring. what about speeding up display VMs by having a spare one per launched? I believe Marek can take that.
Yeah, so this is a trade-off between disposable VM startup time and memory usage. Because if you want to have this VM prepared, like pre-launched, it will use some memory, and memory is kind of precious on the Qubes. So I'm not sure. Well, if you have a lot of RAM, it's probably a good idea. But if you have 8 gigabytes or even 16, that's probably not the thing you want to enable.
Yeah,
but
I have
generally,
yeah.
Yes. So, but generally, I think that idea is not bad. But also, this disposable VM startup time is just few seconds. So it's, well, depending on the application, but more important is, I think, fast SSD.
Yeah, I agree. I have 32 gigs, and I keeps complaining on like killing my like I have like Jitsy crashing or Chrome crashing. But I believe like I already have too many VMs. I'm trying to divide everything into VMs, and that's why I recently discovered minimal templates. So I believe minimal templates kind of also help to some extent minimize amount of software that is running in VM. But yeah, this is trade-off with the feature set. So it's probably not for the VMs which have to be fully featured. Yeah, I would be glad if we have more unikernels in the system for some purposes. There are definitely some use cases which are well established, but maybe this is other discussion. Maybe this is discussion for later. So the plan.
This is very broad topic, but me too. I'd like to have some unikernels, and there are a lot of use cases. For example, split GPG backend could very well be a unikernel.
So do you see any potential candidate for that, or this is like just
this is some topic for exploration, because there are multiple approaches to unikernels or just small VMs. There is Mirage OS unikernel that can be used for at least firewall, but I think someone have written some image viewer and also SSH agent and maybe a few more. So this is one option. If you are brave enough, it's also even possible to build a template package and install it with this conveniently in your system. But for example, for split GPG, we need there is no such implementation right now that I'm aware of, and we can do either unikernel or have some very minimal Linux running with just one application. So it's something between unikernel and minimal template. This doesn't exist yet, but this is something to explore.
Yeah, and I wonder if there are like kind of, it would be great to have some research or some surveys. Maybe there you already got that answers about most typical use cases. I know that the survey got the question about number of VMs that using, and I definitely marked something which is in higher number of VMs, but I was surprised, like, can you really use so little, so small number of VMs in reasonable setup? And to be honest, maybe there is a kind of list of most used VMs and most popular one, and according to that ranking, this prioritize work, and maybe that list just prioritize which VMs should be first for either putting that into unikernel or either putting that in something way smaller which is ready to use out of the box.
Yes, this is, I think, excellent idea. From my personal experience is that whenever you start any kind of web browser in a VM, it will use all the available memory, regardless how much you assigned it to the VM.
Yeah, I believe my problem is that in the same VM I got my regular browser and Rambox. I don't know if you know Rambox, but it's kind of, you can have multiple Slacks open in kind of one application, Mattermost, and I have like, I don't know how many. There is, all this stuff is definitely like not secure at all, but it's in separate VM in which it sits separate from all the other development workload, email workload, and all the other workloads that I have. But to be honest, like this is really heavy, and I wonder like how the performance of that could be improved if those browser. And by the way, Slack is also a kind of browser based. Mattermost the same. Skype like seem to be also kind of heavy. Not saying WhatsApp and other messengers that I have to use because my customers using that. So the question is like, what we can do with all those big applications. Like either I don't know if we can throw it away. Some people cannot because they have work to be done. Yeah, but that means like very heavy. Some of the VMs which are very very heavy and hard to maintain, and definitely saving on other VMs would be a good thing for us, for those people who need more memory.
Yeah, my personal approach to Electron-based application is to run them in a VM that have a lot of swap and low maximum memory, and it works pretty well.
Okay. Yeah, that's great hint. Okay. Okay, so I believe we have a choice right now because according to plan we should take a break, like half an hour break. Maybe this is too long, and on the other side we can continue with presentation and just try to keep the attention of watchers and everyone who joined. So what do you think? Maybe we can take short break, like 5 minutes, and get back, or are we just moving on? Or 15. Norbert's proposing 15 minutes. So I believe like we will listen our staff that's maintaining the stream. So,
yes, 15-minute breaks sounds good. Should we do that now or have some more questions to answer and then have a break in 10 minutes, I believe?
Do we have any questions? Okay, yeah. So yeah, let's do this. Let's take a couple other questions and we will take 15 minutes break at 8 p.m. UTC. Okay, so what questions we have here? Split everything. By the way, there was a proposal for split everything, GPG carrying PKCS in mailing list a few years ago, but it was never implemented. I'm not sure what split everything means.
I've seen some repository called split web browser or split browser. I don't know the details about that, but it sounds kind of interesting. Let me find.
This is like a couple of minutes ago. Alex, if you can clarify, it would be great. So split GPG is there. I'm using split GPG and even using split GPG 2 with GPG agent. So it's great. Split UTF. I'm not using split UTF. I don't know, Marek, if you can say anything about that.
So there is a support for UTF tokens that you can assign a single token, use a single key from a token and assign the Qrexec policy to watch what key can be used in what VM. So it's kind of there. Interesting thing to explore would be some software-based implementation for UTF or FIDO2 or Web-out framework, because with Qubes, it's kind of useful to have still separated from the web browser some authentication device, but not actual device, but a software implementation that is isolated from the web browser by Qubes mechanism, but still allows you to benefit from specifically anti-phishing protections. That is excellent for UTF devices. And UTF tokens are maybe not expensive, but it is a cost, like I believe about 30 or 40 euros. So it's still something that is very useful for improving user security, but in Qubes, we could do that securely in pure software.
Mm-hmm. So I believe this also can be, this is also a story about TPMs, SWTPM, because so isn't this the same way you can connect this UTF, if there will be software emulation of that, or so even like something software implementation, then you just like creating a cube in which just like become USB device, and it explores these cubes as a USB device or some emulated device to other cube, and in that way you really have UTF.
Yes, something like that. So if someone can copy links to the YouTube, I've just pasted two links.
Okay.
One is to UTF proxy, and the other is the split browser I mentioned before.
Okay, let me do that. This and other one.
Yes, and for UTF proxy, I use that personally, and it works pretty well. There is some delay, like 1 or 2 seconds, but it's perfectly fine, and it's possible this way to use a single UTF token for different applications and have them actually separated from each other.
Mm-hmm. Question for Diplo research participants. What about their experience of already deployed software and software installation?
Mm-hmm. I don't recall that being specifically mentioned. They mostly mentioned issues installing software that they wanted to use.
So doesn't that mean that the base installation, like a standard installation, doesn't have something that they would like to have? Maybe this should be considered.
Mm-hmm. Yes, I think that could be like a consideration for future research. Like there is always the issue of, and I think it's on the FAQ, like why don't my preferences are like the default for Qubes? But I think just this is the regular question that any Linux distribution has, even though Qubes is not really a Linux distribution, which is what are the defaults? And I think going for something sane, like having probably an Office suite or something just to get people started would be a good place. But there is always the challenge of like people, for example, coming from Mac OS or Windows, and them not really knowing the direct translation between, for example, Microsoft Office and, for example, LibreOffice. Mm-hmm. So they may need to figure out like that there is an alternative.
Yes, and this is actually a very interesting challenge because it's in Qubes we have in the installation image we have several things. We have the base system, the DOM0, and we have several templates. Currently, there are 4 of them, like default Fedora, Debian, and 2 templates for Unix. And with all that, the installation media size is already over 5 gigabytes. So if we include all the useful, like all the default software in all those templates, the installation media will be huge. Well, it's already huge. So this is the reason why some of the software that is usually available by default, it's not installed on Qubes by default. For example, LibreOffice is in this category. So there was some discussion about having some different installation media flavors, like one with fully loaded Fedora template, another one with fully loaded Debian template, and another one with just minimal stuff, something like this. So maybe we'll get there, but until we have while we have a single installation image, I think it's also important for usability and accessibility to have it a relatively accessible size. Because if you need to download, I don't know, 20 gigabytes to just have the system installed, it's ridiculous.
Yeah.
I
Agree.
have a point to add to that. So, and something that did come up during research was that I think it was at least 3 of the participants suggested, or at least hinted at the idea of having a personas guide. So for example, if you're an academic, this is how you configure your Qubes. Like you have these compartments, and for example, you may need this software. And so people have different needs. So if there was a simple way to adjust Qubes for your needs, even if that's not when you install it, if there was, for example, there are talks about making it easy to run salt stack configurations. So if that could be something that people could just hit play, wait half an hour while it installs, and have the system more for their needs, that could also be an alternative possibility.
Yeah, I believe like that would be cool. Like I already mentioned that today. But what I see, like for example, there are people looking at Qubes OS as a research platform, like a malware research or whatever, like researching platform. I'm also like looking at it from open source firmware perspective as a researching platform. I tried multiple things with it, and it would be great if somehow I can even share that profile or explain to others, okay, this is how you set up your lab, and this is your virtual lab. Of course, like from my perspective, this is lab. From journalist perspective, this is kind of working environment that they want to have set up as everyone working in the same domain have set up in the same safe way. Same thing probably for other use cases. I don't know, gamers or other. But I don't know if design of that is not kind of something that needs a lot of thinking and a lot of well architected solution.
Yes, so this is a perfect use case for salt stack to customize your installation, to include some software, include some configuration files, etc. For example, Secure Drop Workstation is basically a giant salt configuration that transforms base Qubes into a Secure Drop workstation. And I think it's works quite well for them. We also use Salt for this initial setup, like creating this USB, sysnet, sysfirewall, etc. But also there is some idea to have exactly more choices what initial configuration to choose from, and Marta have worked on some parts of that. Marta, can you tell something more about this part?
Yeah, sure. Okay, what I did was a mock-up for and like an idea to provide when you are installing the system a way to choose, like, okay, so I want to have this set of VMs, like for example personal or work, or I want to add a couple of, I don't know, project 1 VM, project 2 VM that will have a certain set of apps, and things like, okay, I want automatically to set up a Tor connection or not, or things like that, or split GPG. But I think it never went out of a design mockup stage because of time constraints, mostly. But this is, I think, something we could return to once I'm done with the app menu rework that's currently happening.
Yes, so this is also something that could be done, and this is something that definitely requires some input from user research.
Yeah. By the way, hi Marta. Like, that's great to have you here, and that's great that this topic was already touched, and there is some work in background for that. Maybe we'll get back to that next year, for example, with some something that works.
That would be awesome, and I really hope I will have enough time to get back to it, because I think this is something that could be really, really useful.
Yeah, we wish that for you. Okay, we talking a lot, but there are other questions like how about running Windows VM? Is there any issue? Are there any issue right now with that? This is from Ilya.
Generally, Windows, like any other operating system, can be run in a VM, and it should just work. The issue, I guess, the question is about Qubes integration for Windows, and this is in kind of well, maybe not fully dormant state, but it's very little. It gets very little attention from our core team, but recently there are several community contributions to that Windows support, and this is something I hope to find time to include in the official Qubes package.
Yeah, so Marek, do you want to take another question? I don't see any. I see mostly comments.
I think it's time for the break.
Yeah, so let's take a break. Let's meet here 15 minutes after 8 p.m. UTC or 10 p.m. Polish time. So yeah, so like we see here, we see each other here in 50 minutes. Thanks. Okay, so we're back, and I believe we're starting with the next talk, with talk from Thierry about the backups. So yeah, let's play it.
Hello everyone, this is Thierry from SRGO Open Technologies. First of all, thank you all for attending today. I'm going to talk to you about how we can use WYNG backups called Wing to store and restore safe Qubes OS state. Hope you will enjoy. First of all, a quick recap on Qubes OS default partition scheme. On Qubes OS 4.0, there was only one pool for both VMs and DOM0. It was changed in 4.1 to separate DOM0 root pool, which is now a 20 gig separated pool. The proof of concept of today is made like on 4.0. This is what I use like on the Privacy Beast. First of all, we want to know what are LVMs and thin LVMs and why they are relevant inside of Qubes OS. Most of you already know that, but it's still important. LVMs are basically block devices. It permits like to have file system that are clonable at no cost. Until there's a lot of divergence between the volumes that are in use. It also permits snapshots, and it does it like really well, in the sense that you can actually Qubes OS use it like with QVM volume reverts. It stores like one state by default, which means that if you restart your cube, let's say you shut it down, and you realize that you prefer the state that it was before, you can revert it. The same applies with templates. What is WYNG backup? WYNG backup is actually a time machine-like differential backup. It constructs and uses metadata to capture difference only based on the actual LVM that is there. Compared to the state that it already has. To do so, it creates snapshots, tick and tuck volumes to see the difference compared to the metadata that is there. It permits also to prune backups in time, so it permits you to actually do backups every day right now, and let's say to keep one backup per week and then one a month and one a year, let's say 10 years from now. So basically you can do a full backup only once and then store only differences of those backup in time. Another thing that is really nice is that it does deduplication. Deduplication in this sense means that, for example, let's say that you have multiple templates clones, with one of those clones having different software installed for different use case. Only the difference between that clone and the original will be saved. So you can actually have multiple templates, copies that you all save and delete locally because you don't need them, and you can restore them in time when you need them back. Same thing for app VMs, which is really useful for development cycles and stuff like that. As a consequence, it saves a lot of space. For example, if we store Wonix gateway and Wonix workstation, the total backup space for those template VMs will be like 500 megabytes and then 800 megabytes for the other one. So the data that is actually the same for both are not saved twice, just once. Wing also permits tagging of sessions when you do a send, which means that if, for example, I don't know, in my case it's useful because I store all my backups online for the OEM image, and I only store like one session locally on the machine that is to be shipped to the client. This means that if, for example, I'm releasing a new version for a month, I just have like to tag it and then in the description say what it contains as a change if it's relevant. The current state of Wing is actually really stable. There is a proof of concept going on right now on encryption. It's the first attempt going, so please give feedback if it's something that you need. In my use case, I'm not storing anything private on the cloud, but for user backups that would want to be stored in the cloud, encryption is a requirement. There is also no authentication per se inside of Wing as of right now, but there is integrity management that is possible to be done by manifest and compression that is there. And on my side, I'm doing the integrity validation on top of it. We will cover that in the proof of concept later on. Let's remember also that Wing is a project by Tasket, Chris Laprise on GitHub. You please reach him out. This is a quick guide. I will not go through it really extensively, but to use Wing at first, you need to initialize it, which is the first configuration. If we see the first line here with Wing metadir, a meta directory is necessary to actually differentiate local backups, meta directory. This means that you could send the backup to multiple virtual machine or SSH server or multiple cubes to store different content. Each metadir contains like the list of app VMs, LVMs that you want like to back up, and they don't need to be all the same. After that, you specify which VM pool is there, the destination, which can be, as said there, like a Qubes SSH, which means that the cube at the destination will be responsible like to connect to the SSH server. Can be SSH also, which I forgot to write there, and local. In the situation that we use right now, it's going to be a Qubes, and actually we use the thin LVM storage there to store the archive. You select the subdirectory, and then here we specified like the compression, which is BZ2, for the need of being able to use those same backup remotely also. There's a proof of concept made on WYNG backup right now, which is a bash script that permits to restore the content. This will not be covered into this proof of concept, but that would be really useful for other use case. For example, inside of EDS, if we had only like a bash script with the dependencies needed for LVM tools, and that would remove the need to have Python deployed also in EDS. So this is really interesting, and this is ongoing. The chunk factor is defined to 3 here, so that we have a good ratio of the quantity of chunks that are contained in the manifest. You can look the documentation for more information on that, but in our case we wanted it to be efficient also on the network. So that's why the chunk size of 3 is, chunk factor of 3 is used here. The hash type is forced to SHE 256 for compatibility reason. Once again, like EDS will not support Blake 2. The volumes after having the initialization needs to be added manually. Here we give an example like for VM personal private. Let's take note here that we're not specifying Qubes name, but we're specifying LVM names. Here, I covered that. Yeah, here we see like that we can do a send with the duplication. Here I added clean and remap just to make sure in case of volumes that would be removed, so that the tick and tuck snapshot are also removed. This is technical. If you want like to look at it, I would say look at it more in detail. This is just the use case that we used in the current example. You can also use arch deduplicate after having sent a backup, so that all the volumes that are already in the archive are metadata are all taken into consideration to do the deduplication. When we talk about the duplication, basically Wing is using hard links on the file system to refer to a data that was stored in another session on the same archive directory. This is how it reduced the space needed. Here I give an example also to be able to prune. This is really interesting, and we go more in what we need here. Sparse write was added recently. Sparse write is actually used in receive, which is actually the restore command that we use inside of Wing. Sparse write is actually writing directly into the LVM in question instead of recreating a new volume and putting the data inside of it. So when you are receiving volumes from local archives, let it be LVMs like in our use case, sparse write is increasing the performance really highly, which is really interesting for us. But if we want to restore DOM0 root partition, what can we do? Wing can be run from a live USB boot environment if Python is there. That's what we will do in the current proof of concept. This is more interesting for us to do it like outside of the operating system. We could do those restore inside of Qubes OS, but then it goes to the question of but what if the host system was compromised? So doing it externally is interesting. The end goal of it all would be to do this inside of EDS, which we try to do for a while, but we will go through that also in the to-do at the end of the presentation. What is missing as of right now is the synchronization between the boot partition and the root file system of Qubes OS. DOM0 thinks that some kernel initRD are deployed inside of boot. So if you don't restore boot at the same time, there will be a discrepancy between the two, between /boot and root. So that's something that we will see in the to-do later. So for the proof of concept, we restore actually all the LVMs that were backupped, but /boot is not covered for the moment. There's a ticket open inside the WING. So the implication and requirement for Qubes OS to be able to do backup and restore WING. There's a discussion that happened inside of Qubes OS a long time ago related to having auto snap LVM snapshot being created at shutdown through systemd shutdown script. I think this is really interesting, and it should probably be implemented by default. The reason to that is that it permits to user to compare root file systems, so DOM0 states between reboots. In the current example that I will give later on, we have a revertibility of 2 stages, so we can go back to reboots in the past to be able to compare the content of those LVMs to see if there was compromise or anything that we would want to inspect in there. So having a root auto snap permits basically Wing needs LVMs to be able to do backups. So doing a backup directly of the root LVM is not a super good idea, in the sense that the root file system could be corrupted, even if the snapshot is atomic. Doing it at shutdown permits all the logs to be written in the disk and synchronized before shutdown. So this is why I'm doing this. In this example here, this is a quick script. We basically remove the auto snap back if it was existing before. we create the auto snap snapshot in root auto snapback, and we clean it up. The basic here is to make sure that we have auto snap, which is the last reboot, and auto snap back, which is 2 reboots behind. In the case of WYNG here, we take the backup, the session of root auto snap on the next reboot. So we take the state of what was there at the shutdown of the machine, the past shutdown of the machine. So having that deployed permits Wing to be able to do the backups. For app VMs, each app VM, private LVMs, and template VMs, root LVMs can be restored. If you attempt to restore an app VM that is live, you can restore the state inside of the private LVM, but you will have to use QVM volume revert of that app VM private storage. The logic there is that Qubes OS actually rotates snapshots, and when it shut down an app VM, it takes the content that was inside of the private and puts it in private dash back. So if you want to have a state that was restored inside of private, it will be pushed inside of back, and using QVM volume revert will permit you to have that state that you just reverted inside of private. The same applies for template VMs, but template VMs normally are shut down, so it's not really a concern for us in restoring inside of Qubes OS right now. The goal of what I'm talking here is to bring the attention of integrating Wing inside of the backup restore tools of Qubes OS. Here the proof of concept is actually using it outside of it, because what we want is a rescue scenario. Some of my users are actually requiring this kind of setup, and they want to be able to inspect and edit the content of the OEM image later on, so they can actually restore all the cubes, templates, Windows image in the state that it was when it was shipped to it. So template VMs and standalone app VMs are exactly the same, and they don't need, like I said, the QVM volume revert if they were not running. Standalone app VMs, as you know, is a combination of the root and private volume, so it applies the same principle as template VMs here. And here is the demo. So here we have heads booting up Fedora 32 live image. We are using the Insurgo detached sign version because Fedora doesn't provide detached sign ISOs anymore. We're using the live normal version. It Qrexec into it, and now we're booting Fedora 32. That's not going to be long. Sorry for the delay. Doopy doopy doo. Voila, so we're inside of it. Here I'm showing you where the ISO was actually mounted in live, and ISOscan is actually the device where the ISO was found. This is where my scripts are actually present. Here I'm showing you the script that is automatizing the WYNG Python script. Here I'm showing you the prerequisite of paths that are needed to be known by WYNG. Here sparse write is defined because we want to write directly inside of it. We have this part that is needed to be able to unlock the Qubes Lux container, and we will verify the content of the detached sign digest that were present inside of Wing. Here we check for the names of the directories, which corresponds to the snapshot, and here we show the difference in the script to be able to revert root auto snap directly inside of the root volume. and the commands that will be launched on those. We're launching it. We type the Lux decryption key of the volume of the install, and then the script starts by validating like the detached sign digest. We will show the script later on. So we see that the keys match the one that was used. The script validates that the digests are intact, and then the restoration starts. I'm skipping it like really fast here. We see here that only the root volumes had a difference. The rest of the volumes were exactly the same. And I skipped in between, like I said, just to show you what it looks like. So we see that the process to restore all the LVMs took like 40 minutes, which is quite good. So we're back in the state, a trustable state right now. Here I'm going to show you the content of the scripts, like for the validation of the signature and the signing script, and also the manifest content. Sorry, typo in the directory. So those are all the LVMs that were backupped. Here I'm showing you the total size, including Windows 10 standalone machine, which is taking 14 gigs, I think. So here is the cost of storage of all the templates and AppVMs that are there. So we are at 24 gigs for a complete restorable state of the machine, including Windows 10, which was 15 gigs. Here the simple script. Basically we have a digest that is verified like against the signature at the first. So we verify the signature, which validates that the digest is good, and then we validate the digest itself. That's what was the first step of the automatized script earlier. Here the script like that is just searching for vol info, manifest info, and the boot backup that I did, and we output inside of SHA 256 sum, and then we detach sign that digest. Now we're looking at the digest itself. So you see here that measurements are taken like for all of the files that are important for WYNG. So we can guarantee at restore that the state is good prior of reverting. Here I'm searching like for a manifest, a WYNG manifest. It won't be long. This is how it looks like. So it's a chunk mapping with measurements of all the pieces that this volume is taking charge. Voila for the demonstration. So here we're not completely done because the boot restoration is not made as of right now. So it's kind of tricked. My demo is tricked because like /boot was detached sign by head, so we knew that the state was good. The problem with that is that domain 0, the root file system, Qubes OS domain 0, is actually the one being responsible to deploy the upgrades. So dom 0 is responsible to having like the verification digest inside of RPM database. So let's say that you revert in a state that was like 1 year ago, that would not work. because like the state of /boot would be more recent than the state of the root that is reverted. So we need like to find a way to actually store that content inside of LVM. That will be done, but it's not done yet. For eds, restoring /boot will come with some problems because there are counters that are stored inside of /boot which will be out of sync. So it's a question of documentation or trying to deal with it. We could delete actually those counters so that eds pick it up and ask the user to sign it again. Eds as of right now unfortunately doesn't support thin LVM with a lack of LVM provisioning tools. It's quite complicated to actually integrate it. If you have any insight, jump in. That would be really amazing, because if eds has LVM provisioning tools integrated and the wing extract bash script works as intended, then we would be able to actually restore local backups, like the proof of concept that I showed you. This is another story completely if we want to restore from a remote station. That's possible. I am doing a proof of concept right now with rsync.net, which are open to create read-write account with a sub account which is read-only. So you're actually able to store your archive as a read-write account, and then it permits us like to deploy a read-only virtual machine already provisioned with the public key to be able to restore remotely. And this is where it gets really interesting, because let's say, for example, that there is a React OS template that is now existing, or the user wants to actually restore his Fedora template to Fedora 34, but doesn't want necessarily to download the new template and everything. He could just like restore directly inside of his LVM the right state. And same thing applying for disaster recovery over a remote SSH server with the detached digest already signed and reviewed and validated. Here I'm giving you a link to go to WYNG extract, which is permitting you to restore archive. I made a bug report recently. It's not perfect yet. This script is less tested than WYNG, which is made in Python, but we're going there, and it's looking good. Like I said, here if you check the contract by the DOM0 to see if the integrity of the kernel, Xen and everything is good, and you didn't restore /boot, there will be a discrepancy. So there is a need to have like /boot and DOM0 in sync at all time. For the rest I already covered. It's just like more details. I think that's it. I hope you enjoyed the talk, and I'm looking forward to have your questions, to have like restorable state, and maybe, who knows, Qubes OS maintaining SSH server to be able to restore your state directly from their SSH server in the future. Who knows? Thank you.
Wow, that was quite a talk, as always, from Thierry. We get a lot of technical stuff. I will be honest, I didn't grasp everything. Because it's like very, yeah, if you're not using all this technology, it's kind of hard to attack. But I believe like we are open to questions, we open to discussion. I don't know, maybe Marek, you can start with some comments, like what do you think about that, and like, do you see a future of Wing kind of aligned with Qubes OS goals?
Yeah, so that was impressive presentation. Thanks. And as for the future, generally, this project looks amazing, but for having something like this integrated, I think the must-have is some kind of encryption, because we do want to provide some property that the raw data does not leave DOM0 until it gets encrypted. So this is the strict requirement to have something like this included by default. Yeah, and I've seen some discussion also. Asked Simon to propose some tips for choosing encryption there. There was some discussion about that. So maybe I think this would be great to have it included by default.
There is a new branch that I would recommend to check inside of the project, which is at Tasket and WING backup. He's looking for comments, but my proof of concept here was more like to show basically that for a disk image, just to jump on the last discussion that we had, in the case, for example, of FreePress Foundation workstation and being able to back up a deployed state without having credential or anything like that is personal, like or private inside of the disk image. This permits like to clone really fast. And actually in the proof of concept that I've done to answer like Demi's question, of course, I'm restoring outside on a live CD, but the same principle could be applied inside of Qubes OS. And I pointed in with the discussion onto the YouTube conversation. We could actually create a root revert snapshot, which is in read-write. Click on the link there to have the information. And from there, since the LVM thinks that it's a snapshot, you can revert directly into the snapshot and then ask to LVM with LVM convert merge to actually synchronize those changes for the next reboot when the LVM volume is inactive. So if we combine all those concepts with the encryption, of course, like because users storing private information would want like this information to be encrypted. But the present state of WING permits to do that for templates, basically. And what I want to bring is that if you combine Wonix workstation and Wonix gateway, and you apply the duplicate on that, we see that the combined disk space used is actually 1.5 gig for both of the templates. So the data that is duplicated doesn't exist on the backup because our links are used with compressed data on the archive. So this is why I think that it's really interesting in the greater goal of having maybe personas and like having states. This is a dream of mine for a long time, but let's say that we have an SSH server, which is read-only for users downloading, having SSH public key already deployed. Then users could decide, for example, to override their template of Fedora 34, which would now be called Fedora, and Fedora 34 would be directly injected into the LVM, and voila, he has a clean state. If we say, for example, that we want to deploy a multimedia template or I don't know, a communication template, that could all be stored with just the difference in disk image, and the users could directly decide if they want like multiple templates, just consuming local space of the clone differences in all of those LVMs.
Yeah, so this is indeed very interesting. As for the templates, how is the integrity assured here? Is it just this signed digest of individual, I'm not sure, chunks or something, or is there something?
There's the chunks. Those are in the manifest. After that, you have info and info vol, which are linked authenticity. So let's say that you have like multiple snapshots for the same volumes. You will have that information outside of the digest, which point to which original backup had the information. And after that, I showed in the video like the manifest. The manifest has really long lines when the volume in question is in charge of the chunks that he has, and otherwise the shorter lines in the manifest are actually pointing to hard links of other volumes having that information. So if you detach sign a digest created for those manifests, then you have the integrity, but externally. Those are discussions that are happening right now with Tasket to actually do a chain of trust on that.
Yes, and
to go forward.
I assume on Resume there is those digests are actually verified too.
Yeah, you can verify. Actually, like if I was running, I didn't have time for that, like in the video, but I could reboot, for example, and then rerun the script and check the content like of the disk against what was in the manifest on a live boot, for example, or even inside of Qubes OS, like with a restored state that we know that is clean now. So you can check the state of the actual LVM against what is in the manifest.
Okay, so I have some more questions, but I maybe give a chance for someone else first. Do we have some questions on YouTube or?
Doesn't look like Demi asked about compatibility reasons. I believe Thierry, you mentioned some compatibility reasons early in the presentation, but like Thierry discussed that directly in the chat, so I believe this is like addressed to some extent. From what I see, we have Tasket on a call, who's project maintainer.
Yes. I don't know if you can hear me.
Yeah, we hear you.
Yes.
Okay.
Yes.
Yeah.
Wow.
The microphone input for Debian does not work, so I switched to Fedora.
Oh.
And you won't be saying that often. So I don't know if you have any specific questions for me. There was someone asking about manifest verification. Just in its plain state by itself, you know, without additional scripts, Wing assumes that you've kept the local metadata safe in its current V03 release. The next one that's progressing along the V04 is, you know, it's already got manifest verification. So what we have, you know, is like a root, you know, INI file for the archive. And then every bit of metadata, including the manifests, gets verified with its own hash. You know, it's like a hierarchical chain of verification.
Okay. Yes, because I think there are several different use cases. One is the restoring just a single VM or set of VMs or just a templates, assuming DOM0 is fine. But other use cases could be some disaster recovery where you need to restore the whole system on another hardware, or maybe recovery after some compromise. And in those two later cases, you cannot assume having local all the metadata locally.
Right, which is why you'd have to independently do your own verification of the metadata directory, as you know, as Insurgo does, as Thierry was.
I don't know. Maybe it was too quick, but basically, I'm just creating a SHA-256 sum of info, digest, and I forget the other file. And basically, I detach sign the result of the manifest, and that's what was checked as a precondition before restoring the content. So I rely on GPG basically right now because it's not implemented as of right now.
Okay. So I have another question about the requirements for archive storage. Right now, if you want to store the backup remotely, you need SSH access. Is it something strictly necessary, or can you use some simple file server or something? I ask because it's useful to store some backups offsite, and you don't always have SSH access to that place.
Right. I'll try and answer that one. The really by design, it anticipates that you'll want other storage backends besides SSH. But it was easiest for me to start with SSH, because you have a full command set. The assumption, though, is that any other backend protocol that gets added to it in the future has to have all of the basic Unix semantics, file storage semantics, which is actually rather common. I was looking at some different protocols. SFTP has it, and the Amazon AWS protocol S3 also has has hard links or hard link like functionality, and the hierarchical way that files are stored, and the sets of commands that are sent out remotely are already in a form that's pretty much looks just like SFTP commands. So it could be pretty easily shifted over to a SFTP with some work.
Okay, that sounds good.
So one rather annoying potential flaw I've seen in this design is that just to give examples, I'm almost certain that RPM is not robust against a bad database. I know for a fact that it's not that's not really considered part of the threat model. And similarly, I am at all the various storage management stuff is going to generally assumes that the on-disk storage state is trusted. So as a result of that, I imagine that for the case of compromised recovery, the only safe thing to do is wipe the whole disk and start from scratch. So, but what that means in turn, at least in the specific case of DOM 0 compromised recovery, to be clear, but I'm not quite sure how you're handling that situation.
Well, I can take that one. The current state, basically, my disk image, the way that I maintain it is this disk is kept safe, and after that I update it once a month with latest package and everything, and I don't run any other commands. So basically, what you have there is the content of the root 0 that was never connected to anything else. No action was done on that machine. So the only thing I can do at that point is have the assumption that since it was not used in between or whatever, then that the state is clean. But let me get this right. The concept here in the usage of WING would be you take a snapshot at the first time that the system was deployed, and basically at that stage, since nothing was run inside of the template itself, outside of the salt script installing other stuff, is the basic stage that we have. And after that, every time that you update stuff, you should take a new snapshot. But the moment that you do stuff inside of the template, or the same applying inside of DOM 0, then the same question goes over. The reinstallation hypothesis here, or solution, is actually the same in the scenario that I propose. My dream out of there is, let's dream that Qubes OS for some reason stores SSH backup in read-only. I don't know, every month when there is a package upgrades, or when it's the time for a new template, then that stage could be reverted directly inside of the LVM, considering that the user would just have to redeploy the package that he installed, instead of going in situ upgrade or downloading a new template, and basically be able to apply the same recipe for all the multimedia or communication templates that he used to separate his use case. That's my goal here.
Okay, so we are at 9 p.m. UTC. We should switch to next talk. I believe like this is very. I believe this was questioned by Demi. This is great topic, and I believe we could continue that discussion with Thierry during vPub after the presentations. So right now, I would rather like to proceed with the next presentation.
Thank you.
Hello and welcome to my Qubes OS Mini Summit 2021 talk, which will be about SRTM and Secure Boot for VMs and current status of the development progress. My name is Piotr Król. I'm founder of 3mdeb and CEO of that company. I was contributor of Qrexec and maintainer. I co-organized and organized various conferences. I'm conference speaker. I train at various organizations, and I'm former Intel BIOS software engineer. I'm 12 years in business and probably for 5 or more years using Qubes OS. I'm also having C-level position in various organizations, which you can see logos of on this slide. So who's 3mdeb? What we're doing? We are a core boot licensed service provider since 2016 and participant of core boot leadership call. So what means that if you, for example, OEM and seeking for Qubes OS certification, then you will need open source firmware or at least some auditable firmware. And of course, with Core Boot, you can achieve that. So, for example, we supporting companies in getting through the certification of Qubes OS. Other thing that we're doing is UEFI adopting. We also develop UEFI as well as Core Boot. We are also Yocto participants and embedded Linux experts since 2019, what means we take care about firmware of embedded devices, IoT gateways, and similar stuff. We are also official consultants for Linux Foundation FWPDL VFS project, which is project which goal has to deliver firmware updates to Linux-based devices, which can be laptop and all the peripherals connected. So we support companies in enabling this updates delivery. We are also IBM Open Power Foundation members since 2020, and one of our engineers is a chair of Systems of Software Working Group since this year. So what we will talk about today, a little bit about presentation goal and terminology. What is SRTM, SRTM, how it function in our boot chain, and what happened over last year in SRTM and Secure Boot technology. What are the key takeaways from the events and from the presentations, from various meetings, and what kind of challenges this bring, so we can move forward to understand, so we can have one presentation which gathers all the information and move forward with development, having that summary. Finally, we will shift to Q&A. So the goal of this presentation is to discuss state of integration of various SRTM and verified boot technologies for virtual machines. But this has some implications. There are some things that have to happen in order because there are many topics involved. We need some checkpoints. We need some places where we can gather everything together and say, okay, this was done, this is in progress, this is what we have to do, and still we probably will make some decisions in the process. And of course, if we want to enable new developers in the ecosystem and move SRTM and verified boot technologies forward, then of course it's good to have this presentation that gathers everything together. So this presentation is about gathering all this information, and to be honest, quite a lot happened over last year since my last presentation about this topic, and I hope this will be a good resource to move the discussion forward. So let's start with terminology just to have common ground. Of course, I explained that in the past, but so what's SRTM? SRTM is a static root of trust for measurement. So in reality, this would be either something which is code or core root of trust for measurement, which is static. Static means static in time, not static by placing it in root-only memory. Of course, this happens often that the implementation is in that way, but still, the static means this is static point in time. typically at the beginning of the platform booting. So we have some root of trust, which gives us beginning of the word for measurements or for verification, depending on the needs. And this can be either implemented as a code, as some kind of a code, which I will tell you what kind of examples we have, or as a hardware. Secure Boot was used in the title of presentation just like more for marketing purpose, because Secure Boot as a term is technically imprecise. It does not explain what it really is. It is more complex situation. It typically consists of couple technologies, and when we're saying Secure Boot, we typically think UEFI Secure Boot, or maybe we talk about set of various technologies, which I will explain on further slides. So it's better to use verified boot terminology, which means, of course, that we verify every boot stage one after another, and this is more precise term. Depending on the situation, if root of trust is used for measurement or verification, we should use other abbreviation, and this would be more precise, like secure static core root of trust for measurement, static core root of trust for verification, or maybe even some static core root of trust for measurement and verification. This would be more comprehensive statement. In terms of other terminology that I will use, system ROM, which will be on next slide, is a place where boot firmware is stored. Of course, ROM indicates read-only memory. It's not always like that. Very often it can be written because we have ability to deliver updates there. But let's say system ROM is a terminology that I use. In case of a boot process that I will present, it is based on platform initialization and unified extensible firmware interface specification, so PI and UEFI specification, which are maintained by UEFI forum. And according to this specification, we have following boot stages. Of course, there is more, they define more, but the important things for this presentations are SEC, which is security phase. This is first boot phase according to PI specification. It should be root of trust for the platform, but it's not always like that. There are things that can verify SEC phase. There is PEI phase, which is pre-FI initialization, which is kind of second stage, which prepare everything to start Dixie phase, which is driver execution environment. This stage typically detects hardware and apply correct drivers so this hardware can be used in the boot process. And finally, we have boot device selection, and boot device selection is okay, like finally we discovered all the hardware during boot process, and then we're looking for okay, which device we're booting from. Is this USB? Is this SATA? Is this NVMe or maybe network? And PDS phase is about that. So TPM, probably most of you know this is Trusted Platform Module, and this is international standard created by Trusted Computing Group this is standard for secure crypto processors. Okay, so I believe this slide is very important to understand when we're talking secure boot. Typically, when we're talking secure boot, we think about multiple technologies. So on this slide, you can see that on the left we have some SRTM or SRTM, depending on the implementation. And we have typically this is called by AMD PSP, Intel ME, or some boot ROM, some part of SoC. And this piece is provisioned in manufacturing mode to verify signature in certain way. There are some, of course, problem with reowning and various other stuff with open tools for that, but this is maybe different story. And this component do the verification and execution and sometimes measurement of the further phases. And then it starts booting the computer. The first phase is SEC, then PEI, then Dixie, then BDS. Typically BDS jumps to bootloader, and then we're running some operating system. So to explain how the secure boot works, we have three kind of components. First technology that is used is silicon vendor security technology, which covers the S-RTM point and typically it covers sec and pay phase because those components are not covered by the UEFI specification, UEFI Secure Boot specification. So then we have finishing the silicon vendor world, and somehow we have to jump into UEFI Secure Boot world. And this is the place where independent BIOS vendors or IBVs play the role, and they typically glue those two environments in their specific way. And then after that, we can say we have something which is specified in UEFI specification. It is UEFI Secure Boot. What kind of problem we have and what we have to achieve in this Secure Boot world to make things reasonably secure? First of all, it would be great if the SRTM would be reasonably open. So there are some things that going on in the ecosystem that happened over last year, which is one of the things is LibreBMC. Of course, this is more related to server environment, but we hope that this project will evolve, and there are already discussions that it may evolve to laptop environment in form of environmental controller or some other thing, which may play role of root of trust for verification. We will see. So that's interesting approach. Other thing is project of LPM Plant, my other company, which is called LPN TPM, which is more about open TPM, open source TPM with auditable code, with auditable hardware to some extent, because we probably will use off-the-shelf microcontrollers, but the software will be open and the schematics will be open for that, which this can help in opening the SRTM part. Then it would be great if our system ROM, so our blue rectangle, will contain open source firmware. Of course, this is most of the market is not like that, and it would be great if it will not contain binary blobs. So even if we have sometimes open source firmware, core boot stuff, we sometimes have to rely on silicon vendor initialization code or some other components like for graphic stuff. Those are closed and we don't know what's going on. Ideal world would be if those components would be open, then this whole chain of secure boot technologies would be more transparent, and we think it would be more secure thanks to that. And finally, we have our bootloaders, OSs, hypervisors, which every of these OSs and bootloaders use kind of other boot protocol, we can say, or at least, so for example, some bootloaders are created to unify boot protocol, some are created for supporting different boot protocols, and fragmentation in the bootloader OS hypervisor world and lack of compatibility in boot protocols between them kind of contribute to problems with implementation of correct continuation of chain of trust. How this is related to virtual machines? First of all, if we're looking at this chain, we have like similar situation. We're starting with some proprietary SRTM, and then we're going to system ROM, and then we have bootloader, or we don't have bootloader. We may right now just run EFI application, which so for example we can run Zen EFI or Linux directly. But so let's consider bootloader as an optional thing here, and then we can start hypervisor. Then hypervisor starts VMs. It starts with DOM 0 and then probably other VMs. So this is how this relates, because without correctly implemented static root of trust for measurement and verification, the verified measured boot of the VMs doesn't add anything to the security properties of the systems. So that's the point. Without correct boot chain and correctly verified and measured components before starting VMs, the security properties of the VMs are not the one which we would like to have. And the other thing which may help in fixing all this environment is just to ignore SRTM and start to rely on DRTM, dynamic root of trust for measurement, which is like, as I said, the difference is that we're not doing this once at static point in time, but we're doing that dynamically at whatever point in time we want. and then we create another root of trust. This is very interesting concept. This is what Trenchwood project tries to do, but I will not go deep with that here. What we can say that the problems of the static root of trust for measurement and verification definitely leads us to conclusion that maybe this is not the correct approach, because it's very complex and the chain is very long and it is very hard to maintain its security properties. And on further slide, I would like to discuss progress of the development and approaching various problems in this boot chain, which happened over last year. So to sum that up, last year I presented SRTM for Qubes OS VMs. You can watch that on YouTube. There was discussion after that, and there is great feedback from Andrew and Marek. I will discuss what key takeaways from that presentation were. Then in March 2021, Oliver from Vates, from XCP&G team, organized Zen Secure Boot and Lockdown working group meeting, where we kind of discussed what kind of problems we have and how we can attack it, and what we have to solve to make Zen even possible to maintain the security properties during the execution, assuming that secure boot, previously secure boot setup works correctly. Then on Zen Developers and Design Summit, Bobby, also from XCP&G team, gave presentation enabling UEFI secure boot on Zen. And there was also present like kind of design session from Igor Druzini from Citrix, and he discussed VTPM, which is partially related to measured boot, which of course it is interesting that the corporations are pushing in that direction, and I will explain why this happened. XCP&G provided secure boot for VMs. There is also work from Trammell Hudson. He informed about this on OS FW Slack, so open source firmware Slack, and this was related with SafeBoot, and he used software TPM. There are some things that are not directly related. I told you about LibreBMC, LPN, TPM, but I will not talk about that anymore in this presentation. So let's get back to 2020. In my presentation last year, I told you about various root of trust that we have, that Trusted Computing Group defined. What kind of practical use cases of those root of trust can be for virtual machines. Some design ideas, how we can work around the limitations, how we can introduce TPM through QEMU features. We discussed that SWTPM has some interesting capabilities and can be used in various configurations. We can leverage it. There is also this outdated VTPM architecture in Zen. And also I presented how those things can be connected in kind of 3mdeb's dream design, like as a concept, as a solution. So assumption and potential feature ideas for TPM usage in Qubes OS were discussed last year, and the key takeaways were as follows. If we want to build everything, we will not accomplish anything meaningful. We have to build some small pieces. That was comment from, if I recall correctly, from Andrew. And also there was discussion that there are significant difference between various types of VMs. So we have PVHVM, PVHVM, and so on and so on. And PVH seem to be the trend, seem to be the machines, and PVH do not use QEMU, but it use PV drivers. But it is possible to create emulation environment and hook into PVH VMs, and this emulation environment can be in QEMU. So definitely we can use this mechanism to deliver software TPM emulated in QEMU and expose its interfaces to PVH VM. And that's probably one of the decisions and trends that will happen. Also, during the review of the presentation, I believe Daniel or Rich pointed to virtualized trusted platform architecture specification from Trusted Computing Group. So there are some graphics here. I don't want to go very deep with that because it will take too much time. But you can see this is layered approach. At the lower layer 1, we have physical platform which contain physical TPM and physical root of trust for measurement. On top of that, we have virtual machine manager, which is our hypervisor, and it maintains various components, like it maintains its attestation of itself, it maintains virtual platform migration engine, so we can migrate platforms we maintain. Then, of course, Virtual Platform Manager is responsible for handling and creating new VTPMs and virtual root of trust for measurement. And those components are used then by various guests, Windows guests, Linux guests. So this slide shows potential attestation flow. As a first step, we obtain VM integrity evidence from the guest OS VM, where this, of course, that guest OS VM got some attestation. Again, it obtains all the evidence from virtual root of trust for measurement and VTPM. Which may be rooted in a physical environment. Then next step is verification of integrity evidence. Then we can obtain the same. So of course, this virtual machine operates in some hypervisor environment, and that's why we also would like to know what's the status of hypervisor, and that's why we're doing also deep attestation through VMM service, through hypervisor admin VM, we can say, and do the attestation of the hypervisor. And finally, we also verify that site, and if everything is okay, we assume we can deliver, for example, some secrets, or we can allow the VM to operate in certain way. So this is good food for thought. What kind of use cases were discussed in 2011 in Trusted Computing Group. Now I would like to discuss presentation from Bobby, which kind of presented what is Secure Boot, how it works, what kind of key hierarchies we use in UEFI Secure Boot, and then chain of trust in shim present systems, and how those can be used with Zen. Also, various other configuration which Zen can leverage, in which Zen can leverage UEFI. And also there was discussion about some limitations. There was Microsoft CA mentions as a signing authority. So typical rumors are like typical situation about Microsoft CA as a signer of UEFI certificates is that Microsoft kind of dominated this environment, but this is not exactly. This seemed to be not exactly the true, because some rumors say that simply nobody in UEFI forum was able to handle this problem and nobody wanted, and that's why Microsoft stepped out and took over that situation. But that's just a side note to the UEFI Secure Boot. So what kind of things Bobby presented in his presentation? So let's assume that the Secure Boot works. We have all the S-RTM components working. Then we finally jumping to something that we can control in most cases. And first configuration is based on shim and use only PE-COF file. So shim can verify only PE-COF. So in this situation, we're starting as a first stage bootloader shim, which install UEFI shimlog protocol, and then this shimlog protocol, and then shim verifies Zen, and then Zen can use shimlog protocol to verify all the further components in DOM0. So there are some minor problems here. It will work only with PE-COF file because that's what's supported by shim. It will not work with any legacy multi-boot 1-2 binaries. And that means, of course, that Zen will have to maintain multiple build targets, what is a problem, and we would like to avoid that. This configuration can also work with not unified and unified Zen EFI. Not unified means that the command line and params for starting hypervisor are not built into ZenFE. Other configuration which can be considered is not starting Zen EFI directly from shim, but use grab as an intermediate player. What this gives us? This gives us ability that grab contains something called verifier framework, and this verifier framework gives ability to use different signature schemes. So we don't only have to use UEFI and X508, X509 certificates, but we can also use GNU-PG. So verifier framework and first implementation of support for Zen Multiboot was done by Daniel Kieper and presented on Platform Security Summit in 2018. And these patches were picked by XCP and G team. And yeah, there is ongoing discussion on ZenDevil how to address that and if it is even possible to get rid of multiple binaries for Zen. So what are the key takeaways? Based on Bobby email to ZenDevil, the key goal is to achieve Zen binary that can be verifiable with shim, the same binary. It can be booted on BIOS platform with grab2. It can be booted on EFI platforms with grab2 or EFI loader. So yeah, so that's something that will reduce the number of build targets, and of course like improve the ecosystem, but it's hard to address all the needs. Yeah, so and there is other important thing that Bobby highlighted. Linux and Zen suffer from the same issue, which is potential of using some of the advanced feature and debugging feature, tracing features to subvert the runtime security properties provided by previously well said UEFI Secure Boot. So there are some advanced features, some debugging features that may just help in subverting the security properties that we achieved thanks to correctly booted hypervisor or correctly booted kernel. Linux kernel addressed that through Linux kernel lockdown effort and feature. And yeah, so that means that Linux kernel locks down some features, and even root cannot use those features. To avoid the situation that we lose security properties, there are various levels for that, and there is a link here if you are interested in that topic. So Zen lockdown have to be addressed, and the Linux kernel lockdown will be treated as a model solution. But the problem with Zen lockdown is that it will not fix all the issues, because the nature of DOM0 and its superpowers as a admin VM are also problematic, and we have to somehow take care of that. And Linux kernel lockdown will not finish all the problems, because DOM0 still is kind of admin VM and can subvert some security properties. This is quite complex, and yeah, so hopefully we can discuss that after the presentation. From open source firmware perspective, we think that Qubes OS and Zen project should think how to not break the firmware updating methods while implementing Zen lockdown, because this is easy to implement all the security lockdown mechanism, and then of course not being able to deliver firmware updates or rely on kind of SMM based updates, which is other problem. Of course, SMM is a attack vector, and we know about that, and we would like to avoid it as much as possible, because it's rather assuming proprietary IBV path of solving the firmware update problem. In terms of other discussions, there was a Igor presentation about reviving VTPM 2.0 architecture, and of course this is motivated by some certification, this time from Microsoft. It's called Microsoft Server Virtualization Validation Program. It looks like they will require TPM 2.0 for Microsoft Server VMs, what means that the hypervisor have to somehow deliver that. Certification will start very soon, so I believe this effort of introducing virtual TPMs into hypervisor world will accelerate in coming months. If we can talk about other work delivered by XCP-ng team, first of all, Bobby gathered various patches and various tools that are needed for enabling secure boot in XCP-ng, and there is a GitHub repository for that. VMs, virtual machines which use OVMF, so UEFI package responsible for delivering firmware for virtual machines, can already use secure boot. And you can, if you can correctly go through setup menu, BIOS setup menu of that VM, you can do the provisioning. You can so you can deliver all the certificates. You can include Microsoft certificates, or if you don't want, you may just include your certificates. So everything from the UEFI specifications perspective is supported, and you can even compile OVMF with built-in certificates and just support what you need. So that's good thing. And there is discussion thread on GitHub issues of XCP-ng project, and of course, like big kudos to XCP-ng team for picking that up and moving that topics forward. In case of meeting that happened in March 2021, which gathered quite big crowd. There were many organizations, many individuals there discussing secure boot and lockdown. The key accomplishment of that meeting was to gather requirements for Zen lockdown. Linux lockdown basic stuff seemed to work fine with Qubes OS. Marek mentioned that there were some minimal tests to look into that. Probably we can talk more about that after this presentation. And we narrowed down some work items that have to be done for Zen lockdown. So one of the things we have to look into is live patching, Qrexec, priv command, PCI pass-through, QEMU, but PVH probably will eliminate or reduce that, and also how we want to protect command line and which things are secure, which are not secure. This is like wider discussion and more complex thing. In terms of open source firmware Slack and Tramel's work, Tramel and couple other people work with SWTPM, Qrexec, and SafeBoot. They proved to run couple scenarios. And why is this important? It is important because FWTPM is best candidate for serving as a virtual TPM or to deliver virtual TPM properties. Of course, in long run, we would like to be rooted in hardware, but this is complicated stuff. We have just this VTPM architecture, which is already outdated. But getting back to what Tramel and others did, they did testing in QEMU with Coreboot and heads, and they emulated as SWTPM to prove provisioning of heads works fine. They also proved that with OVMF, so with UEFI environment. They did attestation in above cases, so that's very good. So they use SafeBoot for attestation. They KX'd Windows, and they saw how Windows interacts with TPM, and they added this support in SafeBoot. So yeah, so that proves that SVOOT TPM is good project, healthy project, can be used in various scenarios, various interesting scenarios, and we should look at that and maybe adopt that in the virtual machine environment. Yes. So to finalize this talk, so first of all, we have many different problems in many areas. We have Zen lockdown problem. We have secure boot, working secure boot problem and the complexity of it. So it's not. It will definitely take time to enable all necessary components. But it is interesting that some of these concepts are on corporate agenda, and there are resources that will push that forward, and that's good. There is this collaboration or even support from bigger organizations. So there are resources. There are some resources to move that forward. Of course, we would be glad to see to make it faster, but it's not always the case. Verified boot, including UEFI, have a lot of needs, and this is something that we're talking from open source firmware consulting company perspective. We would be glad to have more open hardware for root of trust. I believe RISC-V is one of the way to solve that, or there may be other open ISA which address that. There's problem with correct even with the current configurations. There is problem with correctly implemented chain of trust, because there are bugs in either independent BIOS vendors code, either there are tools which are not available for provisioning, which is next case. There are many problems here, yeah. Despite verified boot for VMs does not need those properties, but still we have to rely on the previous components in boot process. So yeah, previous components have to be secured in correct way. That's why we need good tools for provisioning, Intel Boot Guard, hardware validated boot, and other hardware security mechanism. And finally, covering hypervisor and DOM 0 with verified boot is also challenging, and that's where Linux Zen lockdown going. That's where Linux lockdown mechanism may help a little bit, and then yeah. So we have to think what's the best for the VMs, and shall we use UEFI Secure Boot? Maybe there is a way to use Core Boot, vBoot for VMs, and I already saw that as a solution in some cases. So yeah, so there are many challenging problems to be solved as a part of the SRTM and Secure Boot introduction to the virtual machine ecosystem. Okay, and that's it. Thank you very much, and I'm waiting for your questions. Yeah, I kind of watching myself see that I'm repeating problem and complicated too many times. But yeah, we have Daniel Keeper. Daniel.
Can you hear me?
Daniel. Yeah, we hear you.
Okay, perfect. Great.
That's great. It's great to have you. Have you here? Thanks for joining so late.
No problem. You're welcome.
And maybe like quick question, like what's your thoughts? Definitely, like I relied partially on, like I believe Bobby and my talk relied partially on your work which you did in 2018 and presented at PSEC, and yeah, kind of this seems to be continued, and there is still discussion on Zendevil. I even saw your recent replies. I believe everyone who's watching Zen developments may see that discussion. So what are your thoughts, how this can be moved forward, and what are the correct ways of moving that forward?
I think the most important thing is to get feedback from the Linux community, Zen community. As I remember correctly, Jan was replying to some emails. So at this point, I think that I'm not sure that Bobby is still working on these patches or not.
Yeah, I believe they are still interested in that. I hope that Bobby will join. I invited him. Yeah, I see Trammell like bombarding us with questions. So I don't know, Trammell, if you want to join, I just can post the Jitsy link. So if you want to join, just feel free. I'm pretty sure that XCP-ng team will continue that. They have repository which gathers everything together, all the patches and all, like just to build something. But as he said in his presentation, he cares mostly about something which is compatible with the both UEFI and legacy stuff, because they have customers they have to support with legacy stuff. And I believe even like when we consider one of our customers, which is Protecti, who's shipping some of the hardware with core boot. So yeah, this is legacy boot flow, and they want to be compatible with that. They want to, not create another XCP-ng distro to just like support legacy installation.
I think the most important thing at this point is to discuss how to solve some issues which are brought up by Jan, I think. We discussed some, as I remember correctly. Unfortunately, I didn't remember at this point whole discussion, because it happened at least 2 months ago. So I think that at this point I would try. If I was doing that, I would rebase the patches on top of the latest Xen and repost them on Xendevel to discuss the patches further. I'm happy to send my comments and observation to this. Unfortunately, I'm not able to work on these patches, even if it is this is interesting for me, but I'm happy to help with comments at other things. So the most important thing is to rebase the patches once again and to post them, to take account sent by Jan and me, and then continue the work on the patches.
So I believe the discussion started at the point, like first you gave the PE header in kind of assembly form. It was rewritten to, like, at least Bobby tried to rewrite that to C, but he faced some struggles with 64-bit, and eventually he kind of gave up with that's kind of limitation of the modern environment that he faced.
The problem is I tried different ways to solve that. Of course, the simplest way to do that would be to implement it in C, but I also encountered various issues with that. So I decided to implement this in assembly, and I think that at this point this is the simplest way. I also tried, as you may saw from my comments on the Xendevel, I tried to use the linker to generate properly organized Zen image, which can be loaded directly by EFI and also by multi-boot 2 protocol. But I encountered also a few issues. The problem was that the multi-boot protocol requires from you that I call it the image has to be linear. So at the beginning you have to have a header, and then later you have to the code, then the data and the BSS. And in this image you cannot have any holes. It means that if you have an image, you load it into the memory, and the organization in the memory and in the image has to be the same. So you cannot have a situation, for example, like in case of PE header or ELF files also, but we are talking about PE here mostly. So in case of PE file, you can have an image which is linear in the file, but if you try to load it through UEFI, then UEFI interprets the header and put into the memory in a bit different organizations. For example, you can have a holes between the data, the text data, etc. So this is the problem for multi-boot protocol. So you have an image. You have an image which works for multi-boot protocol and for UEFI, for plain UEFI, if you want to load then .EFI directly from UEFI. And this is difficult. Only way which I found to do that is to do this in assembly. Maybe it is possible to do that with newer tools, because I was playing with that. I think that it was 4 years ago or something like that. So currently we have new bin UTC, new linkers, etc. So maybe it is possible to do that. I'm not saying that it isn't. So maybe it makes sense to check once again this linker, let's call it linker way, and maybe I think it would be nicest way to do that, because my expectation is that it would be possible to specify the layout of the file. Jan would not agree with me. Okay, the layout of the file and the layout in memory using the linker script. So that would, in my opinion, that would be the nicest thing to do that. Of course, probably you will have some tooling which maybe after that reprocess this file or something like that. We can compare this thing to the current ELF Zen image generation, because currently, of course, you compile the Zen source, then you link it, and after that you can have an ELF file which have to be reprocessed by special tool which is attached to the Zen source, and this tool generates the final file which is loaded by grab into the memory. So maybe we can use that way too. So there are a lot of options. I think that all of them should be discussed on Zendelvel or maybe on Zen Summit or something like that. I can give some inputs to that discussion. I'm happy to help. So feel free to ask questions. As I said, I'm happy to help.
Yeah, I believe like Tramal had some questions, and this connects a little bit with CSM and like legacy support. How long we have to support that? Tramal, can you elaborate on that?
Well, I'm quite certain that we will probably have to support BIOS compatibility for the rest of our natural lifetimes, at least till at least until the end of time in 2038, when the 32-bit time keys finally force people to move to something newer. But it seems like a lot of the complexity regarding supporting the grub and multi-boot shim interfaces revolved around having to support sort of the legacy CSM. So I wonder, are there customers who definitely require that? Or does it make sense as a community to start pushing people towards the more modern secure boot protocols?
Yeah, so on one side, I completely agree that it would make sense to push people forward. I love the Qrexec stuff you're doing and other people doing. I would be glad to jump into that, but when I'm looking at, let's say, open source firmware customer base, they are not yet there, and they will be not there for a couple more years, or I would say maybe even 5 years or so. So Qrexec, when I try to pitch Qrexec point of view, like many people understand, saying, yes, this is very nice technology, this is beautiful and great, but it seems like an experiment, and like we don't know we want to take the risk of that experiment. Yeah.
Well,
so that's
and even if for the non-Qrexec sort of systems, booting the unified Zen plus kernel, initRD, config, and everything, that works with a commodity UEFI system that you don't need any special open source firmware to make that work. And it gives us, I think, the best security posture. When I looked at it a little while ago, I didn't see any way with the shim protocol to validate signatures on the initRD and some of the other components. Is that still the case, or is there a way to do that?
No, because the problem is that each stage should verify the next stage. So if the UEFI loads the shim, so UEFI should verify the signature of the shim. Then shim loads the grab, so shim should then verify the signature of the grab. So after that, the grab should verify the signature of the kernel, and the kernel should verify. Maybe not. Sometimes you can, of course, you can sign to some extent. Using the detached signatures, the initrd. Of course, this is possible, but the kernel should verify all things which are initrd.
But Daniel, Daniel, I'm not sure if this is correct, because shim can install shim log protocol, UEFI protocol, and this protocol can be then used by Zen to verify DOM0.
Then, but the shim, of course, the shim install the shim protocol, and the grab relies on the shim protocol, of course. But when you call exit boot services, then the shim protocol is dead, so you're not able to use it to verify the.
Okay, so
it is too late.
But Zen doesn't call exit boot protocol or exit boot services. Zen uses, if secure boot is enabled and you're not booting it, Zen will call into the shim to verify the kernel.
Zen cannot call to the shim because currently exit boot services is called by, if I remember correctly, it is called by bootloaders. So in this case, get the grab. So everything is
I think that's no longer the case, because there is multiple to FE. There is a tag to tell grab to not call exit boot services, and
right, you are right. Yes, I was writing that code, but I forgot. Sorry.
When I was writing the unified Zen code, I'm fairly certain that I saw that it calls the shim protocol to verify the DOM0 kernel.
Yes, it does.
Yes. Sorry, you are right. I totally forgot about that. Sorry.
Yes, but
Demi wants to say something, so Demi jump in.
Okay, so what I was going to say is it's also possible for grub to verify, in addition to the DOM0, init ramfs and command line, in addition to the kernel, and therefore it's not necessary for the kernel to verify the. At least I'm almost certain that it is. I'd be highly surprised if it isn't, and therefore the kernel should not have to verify the command line, kernel command line, or the init ramfs, which would be. Because honestly, the idea of the kernel, my understanding is the Linux kernel generally trusts command line, so it would really be up to the bootloader to verify the DOM0 kernel command line. And
yes, it is possible. Currently, we have the infrastructure in the grab to do that, and it is used to measurement. So I think that we can use more or less the same infrastructure to verify the signatures of the kernel, insert everything. It is possible. This shouldn't be a big deal to do that. In general, currently the grab has something which is called verifiers. So this verifiers layer does various verification for various types of files. So you can attach your verifiers to this infrastructure and do various kind of verifications. And these verifiers are used to verify the signatures of P files, in this case Linux kernel, and it is quite small piece of code, so it works pretty well. So as I said, you can use it to also add other verifiers and to do measurements or verifications.
Does it currently support any kind of detached signature, either GPG or anything else? Or because I've seen TPM integration to measure, yes, but what about signatures?
Both things. I haven't played with myself with PGP, But as far as I can tell, there are some people in the world who are using this functionality. And also TPM measurement relies on the verifiers infrastructure.
Okay, so how does it work with Microsoft requirements for Secure Boot? Is it possible to make grub to actually enforce to have anything that is booted to be verified first, or is it just up to the configuration?
I'm not sure I understand the question. Could you clarify?
Because I think Microsoft requires, if you want Microsoft to sign a shim with your key, you need to ensure that anything that is started in ring 0 is verified. Otherwise, Microsoft will revoke your signature. So is it possible to configure, to build a grub the way that it's not possible to override these requirements in
Yes,
configuration?
In general, all binaries which are distributed with distributions does not allow you to run, to load and execute any binaries which are not signed by a valid vendor signature. So you are not able to do that, or of course by Microsoft signature.
Okay, so just as a comment on the choice of grub here, I'm sure you all have heard of the boot hole series of bugs.
Yes.
So
Yes.
my thought was, given that subsequently they did a security audit of grub and found I think over 100 vulnerabilities.
Not 100 vulnerabilities. The 100 of patches which are fixing various issues. In the first round, we fixed, as I remember correctly, seven CVEs, and the second round was the similar number. There was also another. There were also different patches which were fixing minor issues, and we decided to cram them together with the boot hole. Some people call it boot hole too. So we cannot say that we had 100 holes in the graph. We fixed up until now, I think 14 or something like that, around 15 CVEs.
Okay, still that's still a lot of CVEs, and yes. It's a lot of bugs, and also. And for instance, and also I'm for instance with the GPG code, I'd want to audit. I'd want to do an audit of that to make sure it doesn't do anything nasty like read out of bounds. Because I know out of bounds read isn't always exploitable, but still, simply because I looked at the implementation of RPM and it had issues. But anyway, so my thought is maybe we shouldn't be using. Maybe we should use something simpler with a heck of a lot less attack surface.
So on the systems that that I'm configuring for the non-heads-based safe boot systems, where we're interoperating with the commodity UEFI firmware, we're skipping grub entirely and using the EFI boot manager and booting the unified image. So that way we have one thing that we sign that encompasses all of the sort of state of the of that system, and then we can roll out upgrades fairly painlessly by distributing a single file and copying it to a regular file system. So the joke is that no code has no bugs, and so so if the more code that we can eliminate in the boot path, it does seem like it's a good way to both speed things up and eliminate that attack surface.
Yes,
Okay.
I fully agree, and I'm not saying that the graph is a reply to all problems of one size fits all. Let's say I agree. I'm sure that there are some solutions which in which you don't need graph and it is redundant. But I want to say that in general, let's say the graph is a software, so we have bugs, I'm sure. But in general, our goal is to work together with community and find these bugs and fix them as quickly as possible. Additionally, we are looking for other things, how to improve the security of graph. For example, we are thinking about introducing something similar to Kconfig. This way, you will be able to split and compile only just needed pieces of code of the graph which you need in your project. To some extent, it is possible at this point because you have modules in the graph, so it is to some extent it is possible. But we want to improve that. So anyway, on one side we are working on improving the graph, which is as far as I can tell, this is one of the most common bootloaders used in various distributions, and it is able to run on many platforms. I think that at this point we don't have any bootloader which is able to load and execute it on such many platforms. So you can use it on MIPS, on ARM, on RISC-V, etc., etc. So this is one thing, and also we are working on improving the security because it is very important for us. We are aware that there are bugs, and we are going to fix that, and also we are going to improve overall security management in the graph. So this is our goals.
Okay, I have to cut here because like we are like 2 minutes over time. Like please join the link that I sent. Like there are many people waiting in the other room, and I believe we can easily continue the discussion with wider audience, with people that can more openly ask questions. And like I'm open to sit either to the morning hours to drive this discussion further. Of course, if you have time, if you want, and but we would like to close this session and close the Qubes OS Mini Summit for today and close the YouTube stream.
Okay, sure.
Okay, so the link is here in the chat. Thank you very much.
Okay, see you. Bye.
Thank you.